تحت ہم انجینئرس کو CPD پوائنٹس اوارڈ کرتے ہیں تھرو دس ویبنار CPD شارٹ کورس اینڈ ادر ایکٹیویٹیز. تو یہ آج کا بھی جو ٹاپک ہے جو کہ امپورٹنٹ ہے اپنے ایریا کے حساب سے اور لیٹسٹ جو ہماری ٹیکنالوجیز آئی ہیں اور جو دنیا کی طرف جا رہی ہے تو ہمارے انجینئرس اس سے اپڈیٹ رہیں, اس سے کرنٹ رہیں. تو یہ اسپیشل ایک آج کا ٹاپک ہے. تو میں جتنے ہمارے سینئرس پارٹیسپینٹس ہیں, ینگ انجینئرز ہیں, ان کو ایک مشن ہے کہ ضرور دیکھیں اس کورس کی پارٹیسپینٹس کو ریکویسٹ ہے کہ وہ پارٹیسپیٹ کریں اپنے پراپر ٹائم کے ساتھ, اور یہاں سے جو چیزیں ہم سیکھیں وہ اپنے ایریاز میں ان کو استعمال کریں اور پاکستان کی ترقی میں اپنا ہاتھ بٹائیں. سلائیڈ جو ہے وہ میں ضرور دکھاؤں گا جو کہ مینڈیٹری ہے پاکستان انجینئرنگ کونسل کے فریم ورک کے ساتھ, کہ انجینئرس کو اپنے کارڈ کی رینیول کے لیے اور جو ٹائٹل ہے ایلیویٹ کرنا رجسٹرڈ انجینئر سے پروفیشنل انجینئر, اس کے لیے CPD پوائنٹس کی ضرورت پڑتی ہے. تو وہ کتنے پوائنٹس کی ضرورت پڑتی ہے اور کیسے وہ حاصل کر سکتے ہیں یہ بتانا جو ہے وہ ضروری ہوتا ہے, کیونکہ یہ اویئرنیس تو ہم ہر CPD میں دیتے ہیں, لیکن ابھی بھی کافی کیوریز اور چیزیں آتی ہیں جس میں پتہ چلتا ہے کہ شاید اس طرح سارے انجینئرز ہمارے اپڈیٹ نہیں ہیں. بیسیکلی وہ CPD بائی لاز کہتے ہیں جو بنے ہمارے پاکستان انجینئرنگ کونسل کے, یہ 2010 میں بنے اور یہ ریوائز ہوتے ہوتے 2017 میں اپڈیٹ ہوئے. اس بائی لا کے تحت جو پروفیشنل انجینئرز بن چکے ہیں ان کو اپنا کارڈ جو ہے وہ رینیو کروانا پڑتا ہے, اور کارڈ ان کو 3 سال کے لیے میکسیمم جو ہے وہ یہاں سے ایشو کیا جاتا ہے. اور جب یہ 3 سال کے بعد وہ کارڈ کی ایکسپائری ہو جاتی ہے تو اگلے 3 سال کے لیے ان کو اگر ایشو کرنا ہے تو ان کو 9 پوائنٹس CPD کے جو انہیں ارن کی ہیں ان 3 سالوں میں پچھلے وہ شو کر رہے ہیں. تو لہٰذا وہ پوائنٹس کہیں وہ ارن نہیں کر پاتے یا اویئرنیس نہ ہونے کی وجہ سے, وہ پوائنٹس نہ ہونے کی وجہ سے ان کے کارڈ رینیو نہیں ہوتے. جب کارڈ رینیو نہیں ہوتا تو وہ کسی کنسلٹنسی کے اونر ہیں, کہیں فرم کے ساتھ وہ اٹیچ ہیں ایز اے سینئر کنسلٹنٹ یا سینئر انجینئر, تو کارڈ کا رینیول نہیں ہوگا تو وہ اٹیچ نہیں ہو پائیں گے. لہٰذا وہ رینیول کرانے کے لیے پھر کہتے ہیں جی یہ 9 پوائنٹس ہم کہاں سے کم کریں, کیسے ارن کریں. تو یہ اویئرنیس اس وجہ سے میں اگلے سلائڈس پہ جو رجسٹرڈ انجینئر ہیں اس کے لیے بھی ہر سال جو ہے وہ CPD پوائنٹس ارن کرنا مینڈیٹری ہیں, اور جب یہ آریز ہائی اپنے آپ کو اپلفٹ کرتے ہیں نیکسٹ ٹائٹل کے لیے ایک ایگزام سے دیتے ہیں, اور ایگزام کی ایلیجیبلٹی کے لیے بھی 17 کریڈٹ پوائنٹس جو ہے ریکوائرڈ ہوتے ہیں. اور اس کے جو تھرڈ ٹائٹل ہے ہمارا انٹرنیشنل PE ہے پاکستان نے جو یہ لائسنس حاصل کیا IPEA کے تحت 2018 میں, اس کے تحت بھی اگر یہ پروفیشنل انجینئر آگے جانا چاہتا ہے انٹرنیشنل PE کی طرف تو اس کو بھی 21 پوائنٹس جو ہے وہ شو کرنے ہوں گے, جو PE بننے کے بعد 7 ایئرس کا عرصہ اس کو لگے گا فار ایلیجیبلٹی. تو 7 years after PE and 21 CPD points will be required along with other documentary proof of the projects and other things. تو یہ فوکس کیونکہ میرا CPD پوائنٹس پہ ہے, لہٰذا میں اس کی تھوڑی سی تفصیل بتانا ضروری ہے کہ CPD پوائنٹ جو अर्न होते हैं वो 4 कैटेगरीज में अर्न होते हैं. नेक्स्ट टाइम नेक्स्ट टाइम ये आप देखिए ये आपके स्क्रीन के सामने जो है वो कैटेगरी सी ए और बी. जी ये कैटेगरी ए और बी को मैं थोड़ा सा डिफाइन करूंगा कि ए कैटेगरी में अगर हमारा रजिस्टर्ड इंजीनियर आरई जो है वो या पी अगर वो तालीम हासिल करता है, पोस्ट ग्रेजुएट डिप्लोमा अगर वो हासिल कर लेता है तो उसको 2 पॉइंट्स मिलेंगे अगर 6 से 9 मंथ्स का उसका ड्यूरेशन है, और अगर 9 to 12 मंथ्स का ड्यूरेशन है डिप्लोमा का तो उसको 4 पॉइंट्स मिलेंगे. और इसी तरह पोस्ट ग्रेजुएट्स डिग्री अगर है तो उसको 4 पॉइंट्स मिलेंगे, और अगर पीएचडी है तो उसको 12 पॉइंट्स मिलेंगे. तो ये आपके सामने है, ये बायलॉज हमारे वेबसाइट पे भी हैं और आप ब्रोशर भी हम डिस्ट्रीब्यूट करते होते हैं. तो ये तालीम के हवाले से अगर वो अपलिफ्ट करता है अपने आप को हायर क्वालिफिकेशंस की तरफ ले जाता है तो ये पॉइंट्स इस तरह तरतीब से उसको मिल सकते हैं. और जो नेक्स्ट कैटेगरी है जिसमें ये वर्क बेस्ड है यानी जॉब करता है, अगर उसको जॉब है तो कम से कम 400 क्रेडिट आवर्स की अगर कहीं उसने जॉब की है जो कि 3 महीने की बनती है तो उसको 1 पॉइंट जरूर मिलेगा. और साल में अगर पूरा कंटिन्यूस करता है तो 2 क्रेडिट पॉइंट्स जो है वो ले सकता है. यानी वहां से क्वालिफिकेशन करके पॉइंट्स एक्यूमुलेट कर सकता है हमारा इंजीनियर, या यहाँ से जॉब करके पॉइंट्स ले सकता है जो कि 2 पॉइंट्स पर ईयर से ज्यादा नहीं मिल सकते. और इस तरह तीसरी कैटेगरी जो है वो ये सेमिनार्स की अटेंड करना है या किसी इदारे की मेंबरशिप लेनी है. तो ये पॉइंट्स हैं जो आपके स्क्रीन के सामने नजर आ रहे हैं कि अगर कहीं इदारे प्रोफेशनल की मेंबरशिप है तो 1 पॉइंट मिलेगा लोकल, और अगर इंटरनेशनल इदारा तो उसके 2 पॉइंट्स. तो ये इस तरह फिर ये सेमिनार अटेंड करके, जैसे आज के सेमिनार में कोई अटेंड कर रहा है तो उसको 1 पॉइंट मिलेगा, और अगर कहीं कोई लेक्चर दे रहा है तब भी उसको पॉइंट मिलेगा. अगर 2 घंटे का है तो 0.5, अगर 2 घंटे से ज्यादा का है तो 1 पॉइंट मिलेगा. तो ये मुख्तसर सी जो है अवेयरनेस है जो मैं आप लोगों के सामने कर रहा हूँ. और इस तरह जो डी कैटेगरी है उसमें इंडिविजुअल जो एफर्ट्स किए जाते हैं, जिसमें कोई पेपर लिख रहा है, कोई जो है किसी कॉन्फ्रेंसेस का पेपर लिख रहा है, या कोई ऑथर है किसी बुक का, या कोई और टेक्निकल रिपोर्ट लिख रहा है, या टेक्निकल कमेटी का कोई मेंबर है, तो वहां से भी पॉइंट्स आएंगे. और वो पॉइंट्स की ये 1.5, 0.5 मुख्तलिफ इसमें ऑप्शन आप देखेंगे तो वो सामने नजर आएंगे, तो अकॉर्डिंगली पॉइंट्स हो जाते हैं. तो इसकी मुख्तसर सी कंक्लूजन ये बनती है कि आरई के लिए, पी के लिए सीपीडी पॉइंट्स अर्न करना मैंडेटरी है फॉर रिन्यूअल ऑफ कार्ड, या टाइटल को एलिवेट करने के लिए, या रिन्यूअल ऑफ के किसी फर्म की ओनरशिप हासिल करनी है, या कंसल्टेंसी करनी है, या करना है, तो ये पॉइंट्स इन 4 कैटेगरीज में आप हासिल कर सकते हैं. और इसकी मजीद एक्सप्लेनेशन और ये चीज़ें मौजूद हैं रिटन में. अगर फिर भी कहीं कोई ऐसी चीज़ है जहाँ पे क्लियरिफिकेशन की ज़रूरत है तो हम इसको ईमेल करें cpd@pec.org.tk. तो इसके साथ मैं जो है अभी ज़्यादा टाइम नहीं लेना चाहता. मैं थोड़ा सा मुख्तसर तारुफ हमारे ऑनरेबल रिसोर्स पर्सन इंजीनियर डॉक्टर सोहेल मलिक साहब का कराना चाहूँगा। इंजीनियर डॉक्टर सोहेल मलिक साहब इज ए रिफॉर्मर, रिसर्चर, एंटरप्रेन्योर and consultant along with his connections with academia as a regular faculty member for the last 7 years and prior industry experience of 5 years. He has been part of developing 10 innovative technology products services, out of which three are successfully startups now. His research activities are generally in the field of structural health and condition monitoring, finite element analysis, energy management, and energy harvesting, composite materials, and additive manufacturing, and unmanned aerial vehicles (UAV) applications. He did his bachelor in mechanical engineering from UET Lahore and MS leading to PhD from University delle Italy. He is currently working as an associate professor and chairman of mechanical and manufacturing engineering department at PARC Austria Franco Scholle AST Haripur. As a regular faculty member, while overall university faculty experience is 7 years. He is one of the pioneers of urban air mobility. His aim is to build the first flying car of Pakistan. So this was a brief introduction. Now I request Honorable Resource Person to carry forward today's webinar ahead. Over to you, sir.
Thank you very much. Let me share my screen. So I hope it's visible now.
Sir, it's being uploaded. Yes, now it's visible.
Just a second. Okay, so Bismillah ar-Rahman ar-Rahim. Thank you very much, Pakistan Engineering Council, and all the concerned resource person there who have invited me. I'm honored and thankful to you that you have invited me in this CPD activity. So the interesting thing was when you were introducing myself and you were just taking the name of the university. So I'll little bit introduce myself as well in the go. But that is a very interesting and important field of emerging field of industry, which is coming to Pakistan, and I thought that I should give emphasis on that so that we can work better on it in the coming days, in the coming future, because we are having a lot of industrial challenges at the moment, and drones have some of the capabilities which can get rid of them. So first of all, I'll quickly again introduce myself so that if something is missing in the initial part. So I'm working as a chairman of mechanical and manufacturing engineering department at PARC Austria Fachhochschule. So it's been always a challenge for the people to pronounce this word. It's a German word, which means skilled institute. So where the institute where you have the hands-on skills being taught. So this is the first university of its type, which is based on the theme of having hands-on skilled, market-ready graduates coming out of the university. Fachhochschule. So it's always a challenge, and normally when I go to somewhere, I ask the audience to speak this word, which is with three syllables. Fachhochschule. Okay, moving on. I'm Alhamdulillah the first man to work on the urban air mobility in Pakistan. What is urban air mobility? Is like having Uber or Green using drones. So you can move from one place to another using drones. So I'm working on the first prototype, and it will be available for the visualization in few months. And apart from that, being engineer and being analyst in different software, I'm the only configured trainer of MSc Adams in Pakistan. Adams is a American software. Now it has been purchased by another country, Hexagon. But that was the software which is was built by MSc Nastran, which is used by NASA. And even now, when they were simulating the landing of rover on Mars, that was simulated in Adams. So proud enough, I'm the only configured trainer of Adams in Pakistan. Moving on, based on my hands-on skills and working in diverse environments of industry, academia, all over the world in different countries, I have at the moment three startup companies. Few more are coming, but one of them is the Dronetec, on the basis of which I'm giving this CPD. Okay, so I just quickly further elaborate my business profile, but on the right side, you can see my social media handles. And this new era, you need to connect with the right-minded people and the people who can be your customers or who can be your resource. So both ways, if you want to connect with me, these are my social media handles. You can connect me with me on YouTube, on Facebook, on LinkedIn, on Instagram, and on Twitter as well. Okay, if I talk about my business profile, Drone Tech is my first startup, and also give its credit to my three graduate students who are doing final year project with me, and we built the first spraying drone while I was working in GIK Institute. They were quite enthusiastic on this project that they completed it, and I always say that turn your liabilities into opportunities. So when it was COVID, and when it finished, whenever we asked a graduate or interviewee or anyone who is coming to us that what did you do, what was your project and what were your outcomes, he simply shrugged his shoulder and said, "Sir, I couldn't complete it because of the COVID." But proud enough, these three students, Uzair, Raji, and another one, these three students were proud enough that they turned this COVID era into an opportunity. And while living in the city of Hyderabad and living nearby, they kept on meeting continuously and they developed the multi-purpose spraying drone, which led to this company, Drone Tech, eventually. So now they have left this, but I had to carry on this my legacy, and I will take it on for further future projects on drones. So I told you urban air mobility, which is UAM. I'm currently, this is the vision I have. This is the milestone I have to achieve in few coming months. Then I also work as a consultant, and I have done a lot of consultancies in different fields. I keep updated with the current trends so that I should not be left behind. I have been working with Sky Electric on some analysis based on my knowledge of finite element analysis, and there was some physics based on heat transfer. Then I started working with Joby services that was also related to some IoT-based and networking-based projects, which involved structures, electronics, and mechanical design, electronic design, and software as well. Then I was also working with Gadoon Textiles for energy-related and safety-related projects. I helped them at that. And recently, the project has not yet started, but I'm in discussion with Diwan Cement. Diwan is a big group, so I have to work for some of their structural monitoring, health monitoring of some devices, some machines, and I have also to work on their energy management. And proud enough, the last but not the least, I am working as a consultant with Ministry of IT. It's a huge project where we have to train the trainers in AI and blockchain in Pakistan, because this is emerging field, and in the last 1 to 2 months, you have seen that how the things have changing quickly in AI and blockchain. So as I told you, I keep myself updated with current trends. So I work with Python and different machine learning algorithms for different use cases. Dronetec is of course the platform which provides me all the opportunities to apply the knowledge which I have learned from AI or blockchain. And blockchain is another emerging technology, and Pakistan is quite lagging behind in that. So we thought that we have to Ministry of IT, led by different visionary leaders and people, thought that we should have the blockchain training in Pakistan, and we should have proper personnel in blockchain, and we should not limit it into cryptocurrency only. So blockchain is being trained. The training is about to start in few days, and then I will be working as a consultant and I will make sure that those trainers have the capabilities so that they can serve Pakistan in the proper way. My second startup is Design Clinic, that is purely for my students based on the skills we have in freelancing. So Pakistan has become a very huge market of freelancing with different skills, specifically some freelancing platforms like Fiverr, Upwork, and many other. So Design Clinic is a startup which is taking the inputs from the skilled students, and they can earn money while working in their universities. So if you have an engineering student who has some CAD skills in maybe SolidWorks or CATIA or POE, or he has some analysis skills in COMSOL or ANSYS or any other MSc add-ons or something like that, so he can also offer his services. So it's a sort of agency which is which is taking the resources of students and delivering it to the market, and it stand out with the highlighting effect that it is 24/7 available. So we are living in that part of region of the world where when we are sleeping at 9-10 p.m., the Europe and USA starts waking up. Europe is 5 minutes beyond, but USA is just on the other side of the globe. So my point is to keep this design clinic open 24/7. So our students, rather than getting them busy in destructive activities, they should spend this time in constructive activities. So I thought to share it with you so that you don't need to close yourself and you don't have to think in a small box. You can think out of the box and you can think of more than one ways of earning money. And of course, energy management is my another field, and I told you that with few of the companies I've worked with the field of energy management, I was helping them. The third and the last startup which I have just recently started is Sohat. That will be working under the slogan of Made in Pakistan, and that Sohat is hoping to highlight the specific soghats of Pakistan. Like if you want to have a specific mango of Multan, or kinus of Sargoda, or chappal of Charsada, or any product of your city. Pardon me if I cannot name it now. So you have Soghat of your cities, and that startup will working on highlighting those products, because we are a nation which are not quality conscious, and that's why we don't produce those products. But my point is to produce quality products and then market them all over the world. Okay, so just this was my business profile, and now I will talk about the points I will discuss in today's discussion, today's CPD. The first one is drones introduction. I will tell you what are drones. For those who don't know, for those who know, you can have some repetition, some practice. Then I will tell you what is the market size of drone industry and what potential it has for us Pakistanis. And then I tell you how easy the drone works, and how it's a myth that is a very complex industry and we are not able to do it or make it in Pakistan. So if I'm doing it and my many other friends working in the same industry can do it, you can do it as well. So I will tell a little bit about it, and then I will tell you what are the application areas where drones are being used, and of course that would be the discussion that what is their potential in that. And then we have the future opportunities in the drone industries. I will tell you where you can invest, or if you have the expertise or skills, you can use them. And my total conversation is about 30 slides, and if I take 3 to 5 minutes on each slide, you can calculate your time. And at times I will also try to give you a poll or a question, and you can, if you have the internet access at the moment, you can search that and you can answer me on that. So I want, it's very tough to engage the people and interact with the people when you're online. Unfortunate enough, social media is off now, but I will try to share this recorded session with you or with the help of PEC. Okay, so let's start. First of all, what is a drone? Drone hota kya? What is a drone? Basically, it has many definitions, and the word drone has come from the humming sound. Bzzz. If you have something sound like that which is flying, that is the basis of the drone. And when it came to electronics. Basically, drone is a flying robot. So a robot which has some portion of automation in it, sensors in it, and self-powering powered system. You don't have to plug a wire into it. It is wireless powered. It has some battery in it. It is a flying robot, and it is controlled through a remote control. So you have some buttons and something in your hand, and you push the buttons and it moves, and as you command it changes. So typical drones are like this. And also sometimes it fly autonomously, so you just trigger the control system, and it starts from a single point and it completes the job you have designed it for and comes back to its initial point without you being interfering it. So most of the drones at the moment are semi-autonomous. They are moving quickly towards the autonomous, because with the advent of industry 4.0, we are looking for autonomous machines. And remember, industry 4.0 has a big portion of drones in it, because industrial revolution, fourth industrial revolution, will be mainly working with robots, and automatic data analysis and automatic virtual world will be into this, be based on if I connect industry 4.0 with web 3. So drones have their specific portion in it, and like chat gpt is for AI, drone is for industry 4.0. In industry 4.0, it has the same level of importance as today we have the chat gpt in AI. And also this drone has some sensors with it, based on which it defines where to go and how to go. So, and lastly, it has a power system which powers everything which is moving into it, and if it flies, it needs energy, so that energy is coming from and through this power system. So these 3 or 4 attributes are connected to a robot, but these are the typical things included in a robot. You can in a drone, you can have drones which have something more or less than that. So it is not only this. Okay, so if I move forward, we have some interchangeable terms used for drones. So if you hear some more terms, they are again drones. It's not that drones are something else and these terms which I'm going to show are something else. So UAV, urban unmanned aerial vehicle, it is also a drone. This is another term used for drones. Only property it has is that there is no person or driver or pilot sitting into it. So UAVs or drones are the same and same things. And also sometimes in some research papers and industrial people, you call it UAS, because it's a system. It has the drone itself, and it is also interacting with the person on the ground or something else on the ground as well. So it is also called collectively as an unmanned aerial system. It's unmanned aerial system. And also I talked about urban air mobility. So if you see the word UAM, it is also related to drones. Only difference it has is that it has a person sitting in it, because it is mobility. Mobility means movement, and urban means within the city. And normally urban mobility means moving yourself from one place to another. So normally UAM is the word used, and many of the big companies are working on that in the world. And many big names, all the aerospace big industries, they are working on that in the case of in the field of urban air mobility, and because it has a strong exponential growth in the future. I'll talk about it in a few moments. Then you have another word related to drones. This is a special type of drones which is used for racing. So you must have seen enthusiast people working in the racing drones, and they have some goggles on to their faces and they can see around how the drone is watching through its camera. So we call it first person view drones, or it is known as simply known as FPVs. They are very fast, and they are very entertaining. So this is something you can have when you are looking for the FPVs. Then you will also see and listen to the word quadcopter. Quadcopter is something which has four rotors. Basically, when we segregate or classify the drones, we classify them into fixed wings and multi rotors. But you will also listen to this word quadcopter because this is the most commonly used drone in the industry, and it has four. Quad means four. It has four rotors, four fans, four propellers which are giving it thrust. So these that's why it is known as quadcopter. We also have hexacopter, we have multi-axial, we have octocopters, and so on. But quadcopter is quite common. And the last word is the RC plane. So some hobbyists, when they use it, they also call it RC plane. Plane means it's aeroplane, it is flying, it is airborne, and RC mean it is remote control. So these are some of the interchangeable terms. I'm going to very basic so that if you don't have the prior knowledge of it, you can get it. Moving on, let's talk about the market size worldwide and in Pakistan about drone industry. And you know that Pakistan is an agricultural country, but also we have done a very good consortium in the aerospace industry as well. You know some names in the military domain, but today's discussion is not related to military at all. So I'm talking about the commercialized uses of drones where we can have a lot of potential. So globally at the moment, if you see and on the specs which I got through, I could get it through different resources. In 2022, globally it was a 29 billion USD market. uh, Compared to many other markets, it's very small if you consider AI or blockchain or other emerging technologies. But it has emerged from 0 billion to 29 billion in within no time. And as I told you, it's part of Industry 4.0, so the speculation is very good for it. And if we compare it with Pakistan, currently the drones which are made in Pakistan, and I could get a source for it, it gave me the figure of 1.38 million USD, which is nothing, which is like one grain of sand if you have a full bucket of it. And this 1.38 million, even I doubt it, because I know all the people who are working in this industry, so I am not sure whether if it is really the amount of revenue they are generating. So, well, market size and revenue are different things, but still, I doubt this value. And if you know how much is 1.38 million, consider with the textile industry, which is the largest export revenue generation industry for Pakistan. It is 5.6 billion USD in as per 2022, and because of the recent economic crunches, it may have gone down than 5.6 billion USD, but it is the effects of 2022. So compare 5.6 billion as compared to 29 billion. So 29 billion is a huge, it's like 8-story building, and 6-story building, and 5 by 6 lane is the first floor of that textile industry. And 1.38 million USD is like a cat standing in front of, or maybe a sparrow sitting in front of that 6 buildings. So it's a very, very small, maybe an ant. It's a very, very small industry as compared to the what world is doing at the moment. So we are not working on it, and I want you guys and interested guys which have the skills which I'll be giving further, you can work on that. Okay, so drone industry is a sub part of aerospace industry. Aerospace involves everything related to aeroplanes and space. And aerospace industry is one of the huge industries of world, and the biggest portion is based on the space exploration. What the Mars is doing, the SpaceX is doing, and NASA is doing, and the Russian space agencies and the European space agencies, what they are doing is a huge part of that industry. And that industry at the moment is 287 billion. It is 287 billion. And if you think about Pakistan, which have a very strong military background, and the projects like GF-17, they have, based in 2022, 50 million US dollar market. They have 50 million USD dollar market at the moment, which is again a very, very minor point. If I see 28.7 billion dollar in a graph, I could never see 50 million. I can't see it even. So we are almost not started. We have just disrupted, we have just disturbed the static friction at the moment. And what are the future prospects? This is the current situation of this market. If I tell you about the future prospect, it is going to reach 583 billion in 2030. It's exponential increase of more than 38% per year. It's huge, huge, huge increase. And this increase can give a huge benefit to us. But based on the rate where we are moving at the moment, in 2030, we will be just 6.5 million USD, which is nothing, which is nothing. So from these three pictures, I can understand that we are at a at a picture where we are almost zero. We are almost zero. Okay, so I think that based on the knowledge I have, and I can see the potential and the usage of that, and I can see what advantages it can bring to different applications. It is there is a huge potential usage of drone industry in Pakistan. Okay, based on what we have talked about drones and what we have talked about the market size, I little bit talk technically how the flight theory works. Maybe most of you are not connected with the drone industry and you have forgotten what you studied in your classroom. And all of you are engineers, and in the lifelong learning process, it happens that if you are connected to an industry, normally when you're working as an engineer, you work on a very, very small portion of that industry. Like I remember in my first job, I studied for 4 years in UT Lahore. I studied about more than 40 exams, more than 40 courses, and the place where I was working, I was utilizing one question answer which I answered in the course of fluid dynamics, and that was related to aerodynamics, and that was related to the same slide shared by Asif Qureshi Saab, I think, yes. He shared that two-pager document with me, and that was present on the scene Photoshop in UAT Lahore. And I just remember that. And when I was doing my job, I realized, oh, I studied so much and I'm applying in industry that small part, but that small part cannot cannot bear a small mistake. So that has to be up to the point, and I know need to go to into the depth of that specific topic. So I just try to give you a glimpse of that flight theory. So how the aeroplane flies? Normally, there are four types of forces. There is one is drag, one is lift, one is thrust, and one is weight. So lift and thrust is the positive forces which keeps that aeroplane in air. So if I just check this small drone, so the thrust will keep it up, and the lift will take it to higher, and weight will try to fall it down, and drag is when it is facing through the frontal part. So if something is coming from the front as a air resistance, it is drag, and the propellers or the engines, they are working against it, so it's thrust. And if you talk about the vertical forces, the lift is something generated by thrusters which tries to lift it up, and the gravity or the weight of the drone is trying to fall it down towards the center of the earth. So if you have lift more than weight, the plane will go up, and if you have thrust more than drag, the plane will go frontward. And aerodynamic force normally is the vector sum of this drag and lift. So it gives to at an angle. So that's why nothing goes directly up. If you go through the airport and you see the aeroplanes, they don't directly go up. They take an aerodynamic force. With the help of thrusters, we increase the lift so much, and frontal drag is becomes so negligible, and with the help of multi-rotors we move it in a way that the plane is moving vertically up, and we call it vertical takeoff and vertical landing, and collectively we call it VTOL. Okay, so just I revise it. There are four forces on the flying object. Drag is the negative force, weight is the negative force. Drag is the negative force horizontally, weight is the negative force vertically. Thrust is the positive force vertically. Lift thrust is the positive force horizontally, and lift is the positive force vertically. And in multi-rotors, we also take thrust vertically as well. But this is the general nomenclature or typical nomenclature. So if you have understood these four types of forces, I move on. Some other names of the aeroplane. So if I'm talking about some specific parts of an aeroplane or aerospace structure, you should know what it does it mean. So if you see in this picture, I have taken this picture from the website of NASA. Uh, we have something called as wing. We have something called as cockpit. Cockpit is the place where the person is sitting or the pilot is sitting. If it is unmanned, there is no cockpit, no person sitting, but it can have a weight, uh, a payload. And wing is the structure or power portion in the aeroplane which increases its lift. So lift is being increased by the wing, and I will explain it in few minutes how does it work. And then we have the propellers which are giving the thrust. So propeller is working on the second, third law of Newton. And what it's working, it is taking the air from the front and it is pushing it back with a higher velocity. So this this creates a change in pressure, and this way the plane tries to move forward. And in the meanwhile, in the simultaneously, the wing tries to produce lift. So the plane is moving forward and upward. So it has some aerodynamic force working like this, and its movements and its maneuvers are controlled by some other things. You can see the elevator, the rudder. The rudder is for its vertical moment about vertical. This is known as its yaw. The ailerons and the elevators try to give it its roll and its roll, yaw. And then the wings, if they have the ailerons only working on the both sides, it gives its pitch up or pitch down. And fuselage is the main central portion of the plane, which has the main portion of the structural portion of the aeroplane, and it has all the other things connected onto it. Okay, so quickly, what you studied is that we have motor or spinner, which is in the front. We have propellers, which is again on the spinner means the motor, the hub part, and propeller is the extended portion of that motor which takes interaction with the air. And then we have the wing and the fuselage, which is the longitudinal portion. And I have given a link where you can go and try this. There is a very interesting quiz where you can take. So if I go to this liveworksheets.com and then click BU7, then you write 7555659OP and enter, put it in your browser, you will see this picture. It's a very interesting small quiz which can help you that what is, there are about 10 parts shown, and you can have them labeled with these lines. So you can label them and you can see what is your score. So we have a cockpit where the person sits. We have flaps where there are some movements, maneuvers of the aeroplane. Then we have the fins, again the maneuvers. Then we have the exit, which is the door where the people are going in or entering. Ailerons, which are related apart, a control surface of aileron, of wing. Then wing, of course, you can see where it is. Then you have the fuselage. Then you have the engine. Then you have the rudder, and then the elevator. So you can have a try after going into this link, liveworksheets.com/BU755659OP. Okay, so you have to drag with the help of your mouse and place it on that red labelers. And then you are finished, you will click and you will get the results. Okay, so I take to the next slide. Okay, here is the exact answer. So I don't know how much you scored, but it was a good way of checking your basic knowledge to the different parts of airplane. Let's move forward. Let's move forward to the basics of aerodynamics and flight theory. How the wing is taking the drone up, how the wing is taking the aeroplane up. That is basically the lift which is created by wing. So lift, wing creates lift, and it has a cross section which is made in a way that it takes the fuselage up. And if you see, I've shown you some different parts of the wing. So let me pull my picture somewhere else so that you are not hindered by it. Okay, so here you can see that the cross section of wing is like a water drop. It's like a water drop, some way twisted water block. And then you have uh, aerofoil. We call this drop shape, the twisted drop shape as aerofoil. So aerofoil is a 2D shape which creates that lift. The blue line is the lift. So how this lift works, before I go to the NACA, I tell you how this lift works is that on the left side, on the picture you are watching, this is some strings of air coming. Air is coming like some strings. So air streams are coming. Some boundaries of are coming, and the aerofoil has a shape. Then when these air boundaries come there, it has a twisted shape. So some of these wind portion goes up, some of it goes down, but the aerofoil is destructed, it is not symmetric. So small port will go up and the small portion, and the bigger portion will go down. And what happens, that small portion has small mass to move on, so it moves quickly, it is faster, and this one is slower. So when there is slow thing moving on and one side there is fast thing moving on, so this space will be vacated, there will be some space vacated. So if there is one more space on one direction on the lower side and less space on the upper side, it means that there is a vacuum, there is low pressure. So it's a natural thing that everything moves from high pressure to low pressure, it is like a height. So if you drop the ball from a height, the ball will go towards lowest potential energy. So the low pressure has lower potential energy. So automatically airfoil will move towards low pressure. It is the same way our swing bowlers used to have the reverse swing in the air. So the ball moves towards the low pressure. Similarly, aerofoil moves towards the low pressure. And low pressure is so low that it nullifies the effect of gravity, and aerofoil tries to move up. So as the speed is increasing, the lift also increases. So it's a very interesting phenomena that as the resistance of the air is increasing, the lift is also increasing. That's why your Boeing or Airbus aeroplane takes a taxi. It runs on the runway for a long time before it taking off, so that when it has the specific lift available on the wings, the pilot pulls up and the drone or the aeroplane goes up. So this is how the lift is being created, and drag is on the reverse side. So technically the effect of drag is, and the weight is less than lift, so technically the drone or the aeroplane starts moving up. Okay, so this is how uh, your lift is being created on the aerofoil. So this structure is aerofoil. And NASA has some specific profiles of NACA, which we call them NACA profiles. And those profiles are available for different properties of this aerofoil. So that NACA stands for National Advisory Committee for Aeronautics. And NACA has different numbers based on different attributes of this aerofoil. And I tell you how these attributes work. But before that, if you go back to this different labeled portion of the wing, the one side is wing tip, the other side is your wing leading edge, trailing edge. Then you have the wing base. Then you have this leading edge, and then you have the trailing edge. And we have the trailing edge. I haven't named it here. Is the place where the wing air is leaving the wing. And if you stand in front of the wing, and the portion of the wing you see in the front view is your leading edge. So this is the leading edge where the air is being taken in. So in the bottom you see this is the leading edge. This is the leading edge of the wing. And if you see the wing from the side, it is that aerofoil shape. And if you see as in a 3D view or in a perspective view, it is like this. Isometric view is like this. And then you have a wing tip here. This is the starting portion of the wing. And this aerofoil is not of the same size from tip to the base. It keeps on changing its size. That is another story, and it is very complete depth analysis of the wing. We cannot do it here, but it has different properties which help based on the fuselage it has and based on the speed this aeroplane has to take on. And then we have the ailerons, which are the control surfaces. There are servo motors attached to them. They move up and down, which gives the moment of the roll of the aeroplane added with yaw so that it can have a stabilization gyroscopic effect. And then we have structural members here. You can see they are ribs. These are the longitudinal parts, and they give strength to the wing so that the air force cannot break it. Then we have the lateral structural parts. These are the stringers, and these stringers are also giving the strength. So based on these ribs and stringers, the structure of the wing is made, and then we have some skin over it which is covered, so you just see a very shiny surface on the wing which is based on the skin. Mostly it is carbon fiber, glass fiber, or some mix of fibers and metals, aluminum based alloys, we call them FMLs. And then there are some aeroplanes, huge aeroplanes, which have fuel in it. So the leading port, the base of the wing normally has a space fuel tank which is sealed, and it has some piping coming into it which cap the fuel tank. And this is the very simplified version of the wing. The advanced wings have lots of things working into it. Like Boeing and NASA have something like Wing of Tomorrow. So yeah, they are working on some latest technologies on the wings, like morphing wings, which they where this wingtip, leading edge, and every dimension can change, because based on the different heights in the air and different weights and different situations, the wing needs different design. So when the designer designed the wing, they try to design it in a way that it fulfills most of the requirements of that aeroplane. But morphing wing is the quite interesting technology in which you can define, you can change the size of the wing, even you can change the aerofoil shape sometimes. It is quite challenging, and there is a lot of potential in the research of morphing wing. But I just wanted to tell you about how this wing is working and its structure. Okay. If I talk about the material of this wing, when we make it for small planes, we use a very common wood which is known as balsa wood, which is very light and it is very easy to machine. But when we talk about the big wings, they are made on carbon fiber or aluminium alloys, and sometimes even work is going on for titanium alloys because they are very good for heat resistance, and they are lightweight and they are specific strength. Yeah, means that the strength per volume is very small. Okay, if I go slightly more into the aerofoil, and this was exactly the assignment which was given by my teacher, and I solved it in the paper of fluid dynamics, I remember, and I worked on this for 5 years. That is the aerofoil nomenclature. You can easily find it on the internet. Basically, what will be the lift angle of this aeroplane is based on angle of attack. It's a very small number, but you can change angle of attack if you have a morphing wing. But mostly the fixed wings are coming with a fixed angle of attack. So that angle of attack is related to thrust somehow, that at which thrust the angle of attack that aeroplane will start flying. And it has a central blue line which is camber line, the chord line, the red line is the chord line. Basically, if you see this aerofoil, the left side, this is its leading edge where the wind is coming, and this is its trailing edge. So trailing edge is very small and leading edge is it's quite circular shape. So air slices here and slices in a way that it is never symmetric. Air from the top is lesser and from the bottom is more. So this creates the pressure difference based on which this aerofoil tries to move up and the lift is created. And if you join the leading edge and trailing edge with a straight line, it becomes a chord line. And if you make these two chord lines, and this top portion will become the upper surface and this bottom portion will become the lower surface. So air is interacting with the upper surface and lower surface of this aerofoil, which in isometric view will become a wing. And within this, if I equally divide this upper surface and lower forces into two equal parts, this blue line will be created, and this is known as camber line. Camber line and chord line never coincides. They can coincide if the aerofoil is symmetric, and symmetric aerofoils we use on some other industries but not here, maybe in boats sometimes. And then you are very much interested in how much this camber is away from the chord line. So where it is maximum away from the chord line, this is known as maximum camber. It is another property of that wing. And maximum thickness is where what is the largest difference between the upper surface and the bottom surface or the lower surface. So maximum thickness and maximum camber gives the size of the aerofoil laterally, and aspect ratio gives the ratio of its this dimension, the chord line, are related to the length of the wing if you see it in the isometric view. So this tells us how big is the wing and how big is its cross sectional length. Okay, so these are some of the properties of the aerofoil, and NACA profile gives some attributes for these properties for maximum camber, for maximum thickness. And if you are a student of aerodynamics, you will further know that what type of NACA profile or any other aerofoil I have to use based on what maximum camber and maximum thickness I need. So Bernoulli's law, we have that. Bernoulli's law is the law which is related to this pressure theory, and it is related to energy, continuity and energy, which is driven from basically Navier-Stokes equation. If I talk about the governing equation, so Navier-Stokes equation is the base equation on which the drones are designed. And if you try to simplify them, it gives energy, momentum, continuity, Bernoulli's law when you talk about the pressures, and then again the Newton third law, because there's equal and opposite force, which is based on which the drones are moving up. Okay, this is some schematic which is coming from a simulation, and you can see how the low pressure is created on the top of the aerofoil and how the aerofoil is trying to move up, and the aerofoil is little bit tilted, that is its angle of attack. And you see how the aeroplane is moving up when it's taking that shape, so it goes like that. Okay. Okay, moving forward, we have flight theory with us, continued, and we move towards propellers now, because wing is fixed and it is connected to the fixed wing aeroplane. But propellers are some aerofoils which are connected to a spinner, to a central point, and they are hovering, they are moving. It's like if I take my drone again, smaller one, so this is the central hub point, and this is a small aerofoil this direction, this is a small aerofoil this direction. So both are moving and they are rotating. So this is propeller aerodynamics, and again the air is slicing into it. Only difference between this and wing is that air is coming vertically from in front of it, and in the fixed wings the air is coming horizontally. Okay, so this is the difference. And you can see I have also shown this. This is the angle of attack of the propeller. So their angle of attack is normally different, and they have a pitch or blade angle as well. And their chord line and their aerofoil is quite different from the fixed wings, and thrust is perpendicular to it. So this is the basic difference between a propeller and a wing. So as you keep on increasing the length of the propeller, it becomes longer. It becomes longer. The thrust is decreasing, but the torque is increasing. So the overall weight will be increasing, and the torque of the weight this thing can carry will increase, but thrust will slow down. So it can slowly move down, and it is also related indirectly to weight. So if the thrust is not enough, also it will not go up; it will fall down. So you have to design a proper propeller length. And normally the propellers we use in small drones are made of wood, nylon, carbon fiber is the bigger one, and fiberglass. Fiberglass is the most common. All of these materials have their pros and cons, their advantages and disadvantages. Wood is easy to machine, nylon is cheaper, carbon fiber is expensive but lightweight. If the propeller size is very high, we try to make it with carbon fiber, but its manufacturing properties and its manufacturing process becomes tricky. And fiberglass, on the other hand, is in the middle. So it has some properties related to the fiber reinforced composites, and it has some properties coming from the other materials. So this is quite cheaper than carbon fiber, but again it has its own manufacturing way. So these are some of the propellers. So they come in different sizes, different attributes, and in a single CPD lecture, I cannot talk everything about the propeller, so I'll try to move on. But that is a very important aspect, and you need to have a very good knowledge of that. And then we move towards RC planes and multi-rotors. I told you if I segregate, I classify the drones into big two portion. One is the remote control planes and one are the multi-rotors. So we have the control planes and we have the multi-rotors. Remote planes are which are done with the remote, but normally they are fixed wings. So typically don't go on their word. When we talk about RC planes, most of the time we are talking about small fixed wing drones. But it doesn't mean that multi-rotors are not RC planes. They are still RC planes, but multi-rotors are normally vertical propellers and they have more than one rotor into it. RC planes have normally single rotor. So on the left you see is a single rotor and it is horizontal rotor, and on the right you see is a quadcopter which multiple rotor. It has four rotors into it. It has multi rotors. Okay, moving on. Then we have our how these four thrusters. Now we talk about the multi rotors. How these are moving up. So we learned how the plane is moving up, the fixed wing plane. Now we talk about how the multi rotors move up. So this drone, if you see in the image as well, it has four propellers and their rotation is very interesting. They are rotating quite opposite to each other. So first of all, they are vertical, and if you see a quadcopter schematic in front of you, it has four propellers into it. And D or B are the blue rotors, and they are moving in the same anti-clockwise, and red one are in clockwise. So remember that the sum torque in any drone will cancel out. Their total torque will be summing up to zero. From control or system dynamics, it is still possible to balance a multi-rotor if it has three rotors, but it is quite tricky and it will take a lot of energy and the system will more or less become unstabilized. So first of all, as a designers, we try to kill all the problems structurally and with mechanics. So the mechanics of the systems tell us that the total torque of all the rotors should be equal to zero. So if a drone is flying here and stable, its total sum is equal to zero. The torque is summing up to zero. And all the propellers are vertical. Then they have a combination of clockwise and counterclockwise. I explained here in the bullets. Then when each rotor rotates, it creates a thrust based on the Bernoulli's theorem and the third law of Newton. So it has some vertical lift going up, that we call it thrust. So the lift is normally when we talk about the fixed wings, but there we call it thrust. Thrust is the force which is going against gravity. So this force is taking all the rotors up, and every rotor has a specific value of thrust. Technically, we call sometimes it in newtons or decanewtons, but in the drone world we are living, we design the drones based on the weights it will carry. So we all normally call the thrust with kgs because the g acceleration due to gravity will remain constant. So it's the mass of the system which is changing the dynamics of this drone. So whenever we are going to design a drone, first thing we ask is how much weight it will carry. So that weight has two portions. One is the live weight or the payload, which is our application weight, and the basic one is the dead load, which is the weight of the structure. So these rotors will have to hold the structure and hold any additional thing sitting on it. So let's see, if you're sitting on my flying car, the rotors will pick all the structure of the drone. It will pick all the landing gear, it will pick all the composite structure, it will pick all the battery available there, everything will be counter into the thrust. Even the weight of the propellers and the weight of the motor which is working behind the thruster will have all the weight added. That will be the dead weight. And if I am sitting on it, if you add 65-70 kgs of mine, 75 kgs of me, it will add more into it. So if you are a heavy person, the flying car has to give more thrust if you are 100 plus kgs. So work on your body if you are when I sit on my flying car. So thrust is based on your weight, and total thrust is equal to total gravity. If that is the case, the Newton's law work and the drone is stable. And if the thrust is increasing, the drone goes up. If the thrust is decreasing slowly, the drone goes down. And if the thrust goes zero, it free falls. So try avoiding this. Okay, so this is how your multi-rotors are working. And if I talk about their movements, normally in drones we have four movements. We have throttle, we have pitch, we have roll, we have yaw. If I talk about the first one on the left, which is throttle, that means the drone is moving up. So if the drone is giving a thrust and the weight is equal to the thrust, the drone is stable. It is stationary here. And now I want this drone to go from here to here. I will give the command to RC plane and it will increase its thrust. All four equal propellers will increase their RPMs and it will start moving up. So that would be the throttle. So the red line, if you see here, it means you are increasing the speed of all the four rotors simultaneously. It is moving up. And if you not increase the RPM of 4, you just increase the RPM of 2. Let's say you increase the RPM of frontal or rear two ones, because always you have to give some name in aerospace structures. Normally what we do, we call them, there are four names, always remember them: front, rear, starboard and port. So if you are sitting on the driver's seat, or if you are sitting in my flying car, your right hand will be your starboard, your left hand will be your port, your front will be your front, and your aft or rear will be your backward. So because it's very tricky in aerospace structure, if you are standing in front of the aeroplane, you will say right, it is left for the driver sitting on the or pilot sitting on the drone. So that's why they have given a nomenclature: front, rear, starboard, port. And so if you have to give the pitch and you want to move forward, you want to move towards front, so what you will do, these two rear will increase their thrust, it will try to move like this, but this drone will try to balance itself based on its gyroscope and its controller, it will move forward. So it is trying to balance itself, but it's not balancing, it is moving forward. So this is how it move forward. And if you want to move it backwards, so what happens, you will increase the thrust of these two as compared to the rear ones, so it will do like this and it will move backwards. So this is how this pitch works. And if you talk about the roll, the side two works. If you go to this bottom one, this one, so what happens, if you are increasing the RPM of these two, it will try to do this and this drone will try to balance itself, and while balancing it, it will start moving in this way. And if because the camera is literally inverted, so you are just watching otherwise, but if I try to do this one, it will start moving in this direction. So whatever it is starboard or port to you, I don't know. Okay, and then we talk about the yaw. The yaw is this movement, which is the movement about vertical. The pitch is about horizontal. It is this movement, and your roll is towards you, out of the plane or into the plane, and this moment is roll. Okay, so this was the roll I told you, right or left, and this was the pitch I talked about earlier. And throttle is like this. There is no rotational movement, it is just upward movement. And then you have the yaw. Yaw is like you are going towards the front top one, this one. So when you will do this, they will try to both will go up, and this is also going down, but they are horizontal, diagonally working. So in this way, the drone will not understand what's happening, and it will start rolling, yawing like this. Okay, so if you want to, if you have a camera, there is a camera in front, and I want to take picture of this side, I will take roll. I will use the you take use of yaw, and if I want picture this way, I will take use of yaw. So I have the sticks on my controller, and it helps in this. The controller is giving the commands to remote control, and it is moving like this. So these are the four basic movements in a drone, and now you can understand how these four movements are working. Okay, quite clear? Okay, now we talk about the motors which are on the back of this thruster or this rotor, this propeller. This propeller has something which is rotating. What is rotating? It's a motor. And those engineers who are electrical engineers and they know how the motor works, that is a very interesting field for them. So drone is not a field of mechanical engineers only or chemical engineers only. It's a field of all engineering fields, all technical people who are working with hands-on knowledge, and they have the theoretical designing knowledge, they can work on it. So let's talk about motors. They are generally DC and AC motors, we know. And in drones, mostly DC motors are used because it's a motor powered system, it's a battery powered system, and it is least troublesome, it is more effective to have DC motors because they don't have the additional weight, and also you don't need specific additional electronics, which have, of course, less losses. In DC motors, normally we have brushed and brushless motors. In most of the smaller drones, even in bigger ones, we use brushless motors. So we call them BLDCs, where there are no brushes. So you, all the electrical engineers, you can go back, you can see that they have the brushes in it. The brush motors, they have higher sizes, and brushless motors are normally smaller and cheaper and lighter. And also, brushless motors have higher RPM most of the time, but it is not a Bible, so it can change. There, but thumb rule is that normally they have the drone which I am telling you. It is strangely enough, it is brushed motor and it's a very small drone. But most of the drones which we use in our industry are brushless motors, and they are DC motors. So we collectively call them brushless DC motors, or in abbreviations we call them BLDCs. There are also servo motors. Servo motors are used if you are having some control surfaces in your plane, like ailerons, rudder, or elevators, as I talked about them. And if you want to move those control surfaces, we call them control surfaces because they control the movements of the plane, aeroplane. It's not like your vehicle on the road, because the vehicle has the steering and the wheels turns, but in the air there are no wheels. So you just change the pressures and change the aerofoil structure, or the cross-sectional area which is coming into the air, and you make it unsymmetric in a way that it moves. So you have servo motors. So if you're multi-rotor, you have a fixed wing connected as well, which we call, if the fixed wing is connected to a multi-rotor, we call it VTOL, vertical takeoff landing aircraft. So this is, you may need servo motors. Of course, it will increase the load on your thrusters, which are giving the front thrust. And then we have the stepper motors. Normally, we don't use them in drones. So BLDCs are the mostly which will be used. So small BLDC motor I have shown you here, which is used in small planes. And if you are, let's say, designing a motor for quadcopter, it will, your designer will give you the RPM and wattage of the motor, the OEM. So it has some rating. What is the rating? Basically, the rating tells you what is the kV and RPM of that motor, and also tells you about the size of the motor, the number of windings and the width of the winding. And before that, you need to know how much payload you are having in your quadcopter or hexacopter. Let's say I'm going for a quadcopter. So if the motor is, and the person tells me that I have to design a quadcopter for 10 kgs, mostly to be on the safe side, I will also add what is this the size of my drone. So let's say let's say I have 500 grams I have to put on these drones, and this drone itself is 500 grams. So the total weight which will be carried on by the rotors will be 1 kg. So I have to give the thrusters not divided by 4, but I will design it for 50% or 2 to 1 ratio. That is known as thrust to weight ratio. So if I designed for 2 to 1 ratio, means that I will make these thrusters that their total thrust is equal to 2 kgs, because 1 kg is the weight of the drone and 50% is the safety factor. So what happens is that if these are 500 grams each thruster, the total weight will be 2 kg. And so I will look for a motor which is, and propeller total, that it will be able to create a thrust of 500 grams. There are more into it, there are other things as well, but I cannot talk everything in this small talk. But let's see, you can easily find it on the internet how to do that, also the literature. So if you are doing photography, you try to increase this weight ratio, and this is 3 to 1, 4 to 1, because the controller will have less problem to stabilize the system, and the photography will be, very stable. And it's 5 to 1 for racing drones, which are FPV drones. They are very high PM, they have high RPM, and their rate of change of RPM is very fast. That's why they move very fast. They have a low torque and high thrust, and also their payload is very, very small. That's why they move very fast. And the RPM is related to the propeller of the size as well. As you will keep on increasing the propeller size, the rated RPM will be changed. But of course, every motor has its rated RPM coming in terms of kV. So the kVs will given by your OEM, and that is equal to the voltages you are giving. So based on the battery you are attaching to this motor, and you have a ESC as well, which stands for electronic speed controller. You have ESC, propeller, and motor. These are the three things connected in a thruster. We call them collectively a thruster. Your propeller, your motor, and there is a device which tells you, it is a motor driver specifically, that what should be the RPM of this motor. It keeps on changing it. When you give the roll, yaw, every command, the motor will change its RPM. And who will tell this change? ESC will tell this change through the controller. Controller will give the command to ESC that I want to do yaw, and the program will tell ESC that okay, change, ask the motor to change, increase or decrease its RPM. So this per voltage RPM is related to RPM. So your RPM will be connected to what type of battery you are connecting to your system and what is the rating of your motor. And this information you will give into the software of your controller, and the software will try to configure your motors at the end when you are trying to fly this drone. And also, if you know the voltage and kV, that you can simply have the RPM. I'll talk about the batteries in a moment. And if you have very large propellers and low kV, it means that their torque is very high and their voltage is small. And this is normally what you do. So if you have a high RPM, you have low torque and low smaller propellers. If you want high torque, the propeller size will keep on increasing. Okay, so this is how you do the motor sizing. You will see the size or the code of the motor. Mostly, if the motor is very tall and wide, it has more torque because it has more number of windings, and also the core of the winding. Everything this tells about the RPM and voltage. And if you're not the expert of motors, you just have to go to the motor code and gives the stated dia and height. It will also help your mechanical designer or the structural designer to design the motor mounts for it. And for example, if you see it is 20 to 11, 20 to 12, it means that it has a stated diameter of 22 millimeter and height of this motor is 12 millimeter. So this also gives you the size of the motor. And your motor selection depends on definitely the total weight you're going to increase, what is the total frame size, because as you will keep on increasing the frame size, the torque will change and the moment will change and you have to control it. And propeller size as well, that as you are increasing the propeller size to maintain that RPM which is needed for that drone, you need to have a bigger motor. And also the application of the drone. If you are going for the FPVs, you will look for the smaller motors, high RPM, low torque. If you are going for weightlifting or my urban air mobility, maybe I will go for the multi-axial, a motor which has two axes and two propellers working on the same hub. So depending on the applications, you design your thruster, and thruster involves three things: your propeller, your ESC, and your motor. So here we are talking about the motor only. So I give you just a specimen. You can see if you know the frame size, frames of the drone is based on the maximum distance from one end to end, this end. So if I go from this here to here, it's frame size. This is its frame size. Okay. And if the frame size is known, this is a very small drone, but as it goes on, it's not linear scale. You have to think about other aspects, specifically vibration and batteries and moments. As the system goes on increasing, many things get non-linear things which you think are linear become non-linear, and you have to design them. Propeller size needs to be there, that what type of propeller you have to use, and the motor size connected with them, and then the kV rating. So kV rating is connected to the battery you are using. Motor size and propeller size is based on your frame size and the payload and the application which you are going to use. So most of the OEMs now, they are giving all these three things as a combination. So they will give you a thruster as a combination. You don't need to worry about which motor, which propeller, which ESC. So if you are just starting to build the initial prototype for common applications, you don't need to worry about. You will tell your RPM, this is your OEM, this is my frame size, and this is how you want to use it. And he will give you a thruster, which is your RPM, your propeller, your ESC, and your motor. Okay, so that was I was talking about the thruster. So we have talked about motor, we have talked about propeller, and we have talked about your electronic speed controller of the motor, that is the motor driver. So these thrusters is one of the main component. What are the other components of a drone? we must have a transmitter and receiver, because you have to do the remote controlling with it. There must be a radio frequency transmitter and receiver, and your transmitter and receiver are synchronized with each other, and they have a range based on your application. So you decide a transmitter and receiver on which application you are going to use that drone. And then we have a battery. A battery is very critical, but based on these three odds or two odds which I have, I cannot talk into depth about battery. But in drones, normally LiPo batteries, lithium polynomial batteries are lithium polymer batteries are used, and normally they are light in size, and they can give a very variable voltage, because the ESCs and motors need very quick voltage fluctuations, and these LiPo batteries have the property of that. All the other batteries, if they have the same properties, they become very huge and heavy. So we need something on the drone which is light and which gives very quick fluctuations on the battery. So you can talk to your OEM again for your batteries, but remember, other than the frame, even you sometimes the frame weight of frame is lesser, and the weight of the motors. The most heaviest part in a drone is its batteries. They are very heavy, and LiPos are the batteries available in the market which are lighter as their other competitors. So that's why these are used. They have their other safety precautions as well. So whenever you are using your LiPo batteries, be careful with their specific safety instructions. You always have to, and it's a strange battery that you need a discharger with it as well. So if you are using your drones, you have to charge the battery and fly your drone. And when you are done with your flying, and you know that for some time you are not going to fly the drone, discharge your batteries. You cannot leave them with your system. You have to remove them from the system and discharge them as well. So there are some other safety instructions as well. They are temperature, they are other aspects, they are short circuiting. So you have to be very careful about working with batteries of LiPo and their storage as well. And another thing related to the batteries is their sizes. So as normally their voltages keep on increasing with their number of cells. So they are 2s, 4s, 6s, and the s keeps on increasing, and that is related to its voltage. So every battery will have its own voltage. So conveniently, if we have higher number of cells, it's a more stable battery. It can give you higher voltage, and definitely it will decrease the load on your controller and your motor. So they will have more air to play. They will be more confidently working, and also it will also increase your flight time. So your flight time is related to your batteries. So if you are going to increase your flight time, you will keep on increasing your battery size. If you're going to keep your motor and propeller fixed, but sometimes, but technically, it is the combination of everything. If you are going to increase the flight time, either decrease the payload or change the size of the motor and propellers and decrease the frames material. So it will keep on increasing your flight time. But if the weight is fixed, of course, you have to compromise on other things. Okay, so it's always a design process where you define what size of battery you're going to use. Controller, of course, is the brain of the drone, and that tells the battery how much voltage you have to give. It gives about you the charging state of the battery. It works on the safety of the drone. It controls the transmitter and receiver. It controls, because what how controller takes command from the transmitter from the receiver and tells the motors that the driver or pilot wants to move in this direction. Some are feedback systems which are given by the pilot. That's why it is known as UAS. But sometimes the controller has to keep the motor to the drone stabilize itself. For example, I'm taking a photo of you and the drone is sitting here, and I'm not telling the joystick to move here or there anywhere. It is stable here. The controller will tell everything to move here. So if there is a gust of wind is coming, the controller will see this change and try to balance this machine again. So it's continuously, the controller is continuously working. Okay. Then you have the GPS system. So if you want to know where your drone is currently at the moment, so you have the GPS sensors with you. So they are taking the images from 3 satellites and they are trying to position you. So this GPS system is required for all the drones which are available in the market. So if your drone is flying in a university or in a ground or anywhere open air, this GPS system will tell you where to move. So if you want it to move from one point to another, and if you are not, if the drone is out of your sight, I am 2 kilometers or 3 kilometers away from the drone, I will, through the maps, I will see where to send my drone to. And this drone, through the help of its GPS system, will position itself, take to its new position. And if you want to increase the accuracy of the GPS system, you have to buy a good one. And sometimes we add more than one GPS systems to increase the positioning system. But sometimes it so happens that you have to fly the drones inward. So that is a R&D direction of the drones, where you have to buy to fly the drones within indoor. And we have a different type of positioning system, because when you are indoor, the satellite will not give signals, or they will be very weak, either very weak or not no signals at all. So the drone will not be able to fly. So that's why we have another classification of drones. There are one type of drones which are indoor drones, and there are another type of drones which are outdoor drones. So normally indoor drones don't have GPS. They work with their ultrasonic and IR sensors and cameras to position themselves. And if they are able to position themselves and fly autonomously, that is very interesting field, and it is quite challenging at the moment, and that is known as VPS. So it's visual positioning system. The drone watches itself and creates an own positioning system, and it tries to locate itself and move from one place to another. So it's a very interesting field of the drones as well. And last but not the least, frame. Everything which I've talked earlier will be sitting on the frame, which is normally made of balsa wood or glass fiber or carbon fiber or aluminium or some other thermosets. So it can be of anything depending on the application and the size of frame you're using. Okay, so this is the complete picture of the platform of the drone. Now we have to decide what is the usage of that drone. So drone is a platform. It's like a vehicle. You want to sell ice cream on it, or you want to make people sit on it, or you want to have a fire spraying system on it. So similarly, it's for drone. So drone has some payload designed for it, and you have designed it. Now you have to put something onto it. So this is the platform of the drone, and now we will talk about the applications. Every drone will have these things essentially into it. Based on its application, it will have more sensors and more compartments and more add-ons. But these are the 6 things which will always be available in every drone. So let's talk about some of the application areas of drones, which is the last part of my discussion. The first is photography and videography. That is the most common usage of drones we have seen everywhere. So you must have seen in the marriages, in some big functions, the drones start coming and they are taking pictures and they are taking videos, and then you see the aerial views or videos, and then the people are using it for recreational activities, for marketing, for coverage, many other different aspects. Another one is agricultural drones, which is field of the agriculture, and that is my favorite one, in a sense that I again emphasize agriculture is our strength, and we need to build around agriculture. We should not listen to what our neighbors are doing or what the Europe is doing or North America is doing. We have to think about something which is our strength. You always play on your strength, not on others' strength. So agriculture is our strength, and we have to build everything on it. And I have connected, that's why agricultural drones, and I'm working on some projects on it. But I will tell you how these agricultural drones are working these days. Logistics and delivery, how these are the drones are being used to taking weight or move luggage from one place to another. I have some products working on this as well. Industrial inspection, my main area is structural health monitoring and condition monitoring, and I thought about drone for the first time, and I was doing some inspection, and it was very difficult to do inspection on that area. That was a very long length. That was a railroad, and if you have to do the inspection of the railroad, the current system which Pakistan Railway has are very conventional and old systems, and there are two teams. They are moving all over the year to inspect the rails, and they are not able to cover it still. So we need some quick and autonomous ways of inspecting the rails, and I had a project on it and I worked on it. That was the first time I started working on the drones with the help of my students, with the help of prototype, with different examples, and I came into this field. So industrial inspection, you can inspect chimneys and many things with the help of these drones, and many industries are working in it. Then you have the surveying and mapping. Surveying and mapping is something which you want to do on a global level or higher image. You want to see where are their heights, there is water, where is trees. So based on this requirements, you have the surveying and mapping, and drones are the quite interesting devices which can do them very easily for you with the help of some of the software. I'll talk a little bit of it. And the last one is the search and rescue. So if there are disasters, or if you're going to search for something and you need to use for rescue, there are also drones which are being used, successfully being used for this use. So these are the 6 main areas I've talked about. More or less everything falls into it. So let's talk about them quickly, one by one. And these are not just the application area, these are also the potential areas where you can work. So if somebody is interested, he can take one of the niche and he can start working on it based on his interest, or maybe he's already working in some of the fields related to these 6, and he can employ or add on, improve his area or industrial area by adding drones into it. So let's talk about photography or videography. So mostly you use a high resolution and very stabilized gimbal. So gimbals don't let the camera to move. And let me tell you one thing. If you are making a video or a photo with DSLR or your mobile, that is less stable than the drone. And you can see my YouTube channels and my videos I will share on my channels. They are quite beautiful and stabilized. You will not never seeing a single moment in it. You would never know that this is taken by drones. So this is a very good thing into the drone. The only problem they have, that they have a noise. Their propellers are moving. Also work is being done on it, to cancel it, but sometimes you don't need the sound. And also if you have a mic on somewhere else which is away from that, so you can take the sound from there and you can take the imagery from the drone. You must have seen many people or the dramas that people are speaking and the imagery is being taken from the drones. So basically they are mixing the sound and videos afterwards, so you can do that. And then FPVs. I talked about FPVs. You wear a goggles and you can see what drone is seeing, and you start flying it, and it looks like you are moving, like you are flying yourself like a drone. So enthusiast people use it for entertainment. And also there are some drone racing competitions which are based on FPVs, and that's very interesting field. So there are very few people working in Pakistan, 1 to 2 3 I know, they are making their own FPVs. The users are many, but there are 1 to 3 people they are building their FPV drones, and it is a large potential in the market at the moment for these. And the last but not the least, very interesting one, are the light shows. About 2 to 3 people are working on this field in Pakistan. It has a great potential, great potential. You must have seen drones making different things, like you see in the image here. There is this flying bird is not a flying bird. There are hundreds of drones flying together. So mostly the swarms of drones, many different small drones with lights on them, are used at night. And the fireworks and these things have become old. Now we have the swarms of lights flying in the air, and these are used for the animations you can think of, and they look very beautiful. And starting from 20 to 30 drones, people have started giving their light shows, and they are very expensive at the moment. A time will come they will become very cheap, and every other function or exhibition or match or anything significant, you'll see these types of drones working on in few after few some time. But currently the one who will jump into the market will be the first to gather more profit. Okay, so this was related to photography and videography and entertainment. Now let's move to the inspection drones. The inspection drones are the drones which are going for the non-destructive testing or the structural monitoring of something. Like I want to inspect a factory. I want to inspect if the temperature is coming out from a chimney, or the fire is letting, or if I want to go inside the chimney and see what's happening inside. There is no crack, or there is no sediment, or there is nothing foreign thing coming into the chimney. I can have specialized drones with lights on them and different types of sensors on them. So structural monitoring is a very common aspect of inspection drones. And I talked about railroads, rail inspections, and rail inspections. The project I'm doing, I'm building a drone. Just wish me good luck. That drone will be able to run on the track. I tell you further on it. It will be moved like a thela. You remember we had a very old system of railway cart. which was taken from one point to another, and even there were thelas which were run by people. They were hand driven, hand held, human powered. And this is a very new way of inspection the railroads. So it will have four wheels which will be running like a rail bogie on the railroad, and the drone will be inspecting. The vehicle will be inspecting the railroads, the rails, for cracks or any flaws, and it will have propellers on it. And if there is a train coming, the drone rotor will rotate and the drone will fly up. So if it is the drone is inspecting the rail, the train is coming, it will fly up, the train will cross and it will start again inspecting without any other user. So it's a very quiet and interesting way. Sometimes people say that why don't you put your sensor on the train and start inspecting. Normally trains are very fast and they are not equipped with that type of damping and other properties, so it's quite tricky to put on it. There are some basic inspections which can be done on trains and which is already being done, but this type of inspection is very time taking and very slow. So if you have some doubt there, it's that the vehicle will move very slowly and it will go into the specific points like where there are bolts, they are foot of the rail, or there are more potential places where you have the slippers in the railroad. There are more chances that there will be defects or cracks. So this type of drone will be able to sense it. And even the roads, our normal roads, you can even use the simple RGB cameras, red, green, blue cameras, to study the roads if there are cracks on them, and you can help the authorities decide whether this road, which is normally needed not much of repair in Pakistan, you can easily define that where are the problems. You don't have to take a vehicle with a very expensive fuel at the moment. So technically, when you are inspecting the drones with cameras or imaging devices, technically there are three types of cameras. You have the RGB cameras, which are the normal cameras. If you are watching me now, it's a specific type of RGB camera with some frames per second. It has frames per second FPS, and then it has some resolution. So every camera has some attributes, some field of view FOV, some frame per second, and some resolution. And basically it's a RGB camera which is based on three colors, and then based on your light conditions you put some lenses on the cameras and you try to capture the type of image you are going to take. So if your inspection is visual, or if you can extract the information from your visual imagery, you can take RGB cameras into action. And now with the current technology of computer vision, AI, you can have some processing, some trained data on it, and if you have some flawed and unflawed system through supervised training, you can easily judge if there is a flaw which you are trying to find in a industry, in a chimney, in a structure, in a bridge, in a road, in a railroad. Okay. Another type of sensor is the infrared or the thermal cameras. Infrared, which based on the infrared of light, which is one side of the visible spectrum of light. These cameras work on your radiations, because you know the heat has three types of modes, which is conduction, convection, and radiation. So this radiation is related to the Stephen Boltzmann law, and you have the infrared imagery of that thing if you take the image of that. So normally the thrusters, so your cameras are connected with RGB cameras and infrareds. Both collectively work to have the drone system working. So these cameras, infrareds and RGBs are sometimes collectively used. And some specific applications you have to move into more than one spectrum. Sometimes you need to very specifically work in some specific portion of infrared, some specific region of visual spectrum, and some specific region of ultraviolet UV region. So these multispectral cameras have the capability to change the spectrum. So sometimes you need to even go for the polarized light, like the animals see the things around. So based on this, you can have different type of inspection system. Such cameras will be discussed more in the agriculture applications, where you have the agriculture drones with you. So you can see, I was just talking to as a keynote in a conference, and I was trying to tell them that how I inspect the system with a very one of the commercial drones. And not only the cameras, I also use some in my research some other very advanced sensors. One of the sensors is the EMATs. They are very new sensors which are used other than the cameras. They are like non-contact ultrasounds. You know, ultrasonic sensors. Ultrasound is used for the human inspection, and ultrasound is used for NDT, non-destructive testing by engineers. So this is a new type of NDT in which there is no contact. So, and it is also ultrasonic based. So if you have something like that, it is moving, and this is a problem with the drones. Not problem, but it is quite tricky. If you are working with drones and you want the drones to do inspection for you, if they are in contact, they have a more load coming on them and they need more working on the stabilizer and the thrusters. But if they are not contact, they are in the air, it will be easier for the controller to control them. So if you have a non-contact sensor like we have the cameras, it will work very fine, but cameras cannot find each and everything. So EMATs are electromagnetic acoustic transducers. I'm working on it. A couple of students have passed out. One student is working on it at the moment. Two students are working on it at the moment. We are working on EMATs where we are trying to find the cracks on different structures. It's roads, it's composites, it's metal structures, and it is railroads. So different types of structures. And we are trying to put these EMATs very expensive, very heavy, and they have the permanent magnets into them, so that they are very tricky. But we are working to devise a way in which we can put the drone system on the sensor system on the drones and find them. And there are other sensors as well. So you can combine EMATs, infrareds, multispectrals, and I'll talk about the lidars in a moment. Lidar sensor is very common, light imagery and sensing. So it's like a 3D scanner. This type of drone sensors are also being used for sensors are being used for this type of imaging. Okay, so moving on. So that was all about inspection drones. And inspection drones are normally very expensive, but also you need to know the governing laws or the basic knowledge of engineering when you are going to work with inspection drones. So let me tell you, there are almost no one working on it in Pakistan. Very few people working on it, and it has a lot of potential at the moment. Let's move toward the next portion, which is agricultural drones. Agricultural drones, which is of course the strength of Pakistan agriculture, and with this depleting resources of gas and electricity at the moment, I would recommend everyone to move towards agricultural lands and use your knowledge in upgrading and value addition in your agricultural fields. And the drones are quite interesting and important things to be used in agriculture field. When you are using drones for the agriculture, it has a very specific field which is known as precision agriculture. Precision agriculture means that you are not going to waste any of the thing, and all the farmers know that. If you are saving your seeds, they are expensive. You are saving your fertilizer, your water, your insecticide, and you are not wasting at every place. You will save a quite amount of energy. And then when you are harvesting, like at the moment wheat is being cultivated and being the yield is being harvested at the moment, you people have seen that people are very conscious about their wheat products. Each and everything of that field is sold, nothing goes wasted. The straw is sold, the remains of this thing which is on the available on the wheat field is sold, the grain itself is a source, and it has an industry being built around it. So if you have drones working on it, and they can save you a large amount of money, they are very fast, and they don't, most of the time they don't use fuel, because fuel is very expensive. And if you are charging the drones through some solar system, you have the potential of using green energy into the drones. So they have the potential of sustainability. Sustainability means using it for a longer and reliable manner, and which can last by on itself. It is not using any depleting resources. Then moving forward, one of the application is the spraying insecticides and fertilizers, and this field is quite becoming quite famous in Pakistan. About 15 to 20 companies have already started working on it. One of my students is working on it. So there are many people who are working on spraying drones at the moment. They have 16 25 liter of a hexacopter or a quadcopter, and they use the remote control. They take the insecticide from you and they charge you per hectare. And this scorching heat of May, June, July, when it is very tough to go outside in the southern Punjab or central Punjab or Sindh, it is very tough to move in the fields and spray. And drones, they will do it for you within no time. So the thing which you were taking for odds maybe 1 to 2 days, the drone will do it in 3 to 4 hours for you. So first of all, you will hire them, they will come to visit you, and they will do the surveying, and then they will give you a price, and they will ask what type of spraying you know. But this is the very basic type of spraying. It will save you some spray, but it won't save you much. The next step is adding computer vision or AI to the spraying. Computer vision and AI means that deciding based on the pictures or videos. So if you have a specific type of tree and you only want that tree to be sprayed, then you use the precision agriculture. You don't waste your spray. Let's say I have a tree of fruit and leaf and the flower, and I just leave and there is an insect sitting on the leaf. I don't want my fruit or flower to be disturbed. This drone can have some spraying systems and nozzle systems where it will just spray on that specific leaf. So that's very tricky, and that is the next step in the precision agriculture. So you will be using spraying drones to precisely spray some part of your crop. And I was talking about multispectral cameras. So multispectral cameras, I just show you this system here. You can see the system here. You have a smart spraying UAV, and then it has some computer vision system, some sensors, and then it has a nozzle based of spraying. And if you want a specific plant to be sprayed, or you want a specific part of a plant to be sprayed, this camera which you see here is basically a multispectral camera. And you work or do a lot of research and we apply computer vision to train your smart spraying UAV to detect where to spray and where not to spray, and you adjust these things. And this AI model will help you in your autonomous or semi-autonomous spraying. Currently in the market, people are just spraying, but you can have more add-ons into it, and it has more potential into it. So you have your monitoring sensors on them. Okay, so you take help of your monitoring system, and you take help of use of computer vision and IoT in agriculture as well. So there is something known as precision agriculture and something known as smart farms. I am working on one in my university in Park, Austria, Fachhochschule. I've requested the administration. It's a very interesting model. You see a professor working in the commercialization and in different fields. I have taken a place, and I am working in a group of AI where we are together working on an agricultural field, where we will be making a smart farm. And the smart farm will be yielding, let's say, tomatoes for 365 days a year. You know that tomatoes sometimes become 400 rupees kg, 300 rupees kg, and sometimes the people or farmers are throwing in the fields or in the canals because they cannot afford the amount of money or the transportation of this tomato into the market. So this smart farming will help us stabilize the flow, the supply chain of crops in the market by making it more productive and predictive. So you really know that what type of crop is coming and when it's coming. So this is really helping you decide the supply chain of the market. And this smart farm, how will it look like? It will be a completely closed environment, and if the soil is there, the sensors will see the soil and tell what is the level of pH into them, what is the level of minerals into them, what is the level of moisture into them. So based on these three things, there will be robots, not only flying drones but also other robots, the ground vehicles. They will come to plow the field, they will come to water the field. Maybe the drone will come to water with this spraying system, and it will be totally automated. The sensors, because they know that we are going to sow this crop, let's say we are going to cultivate tomatoes again, and you are going to put in the seed of the tomatoes, the drone will come and plow the seed. It will put all the seeding, there will be a seed drone. Then it will see that what is the situation of the seeds, if they are budding or not. And then if they are budding, they will see what is their situation, what is their growth rate. And if it is a tomato plant, based on the computer vision, AI, and all the internet of things, it has already decided that after this much of days it must have this much of height, and it must be needing this type of ingredient, whether it needs iron, it needs magnesium, it needs what type of minerals, it needs calcium. So all the things will be available within the field, and whatever is will be required based on the sensors, it will be sprinkled by the drones, or maybe the flying drones or the ground robots, and they will make sure that the plant is growing with the best possible way. And if it is closed environment, even you can control the amount of sunlight, you can control the amount of temperature, you can control the temperature into it, and you will ensure you can precisely engineer your yield, that this field is going to give me this one, and it will not be working only in the season, it will be working 365 days a year, and no more storage of the crops or tomatoes. You will find farm fresh tomatoes all throughout the year. So that is the future of the agriculture I'm showing. Some of the groups are working on them. They have their model farms in Karachi, in Islamabad, in different parts of Punjab. They have started moving in a very good way, and they are making use of the drones. So that is a very potential field, and I request you, please come into this field. It's a very interesting field where you can make use of these things. Tomorrow, if the fuel is not there, if the dollar PKR conversion is not there, at least what you need is, if the university's education is not there, if the internet is not there, at least what you need is food to eat. So if you have an agriculture sustainable system, you will be able to sustain, you will be able to live. Otherwise, you will not be fighting for dollars or liters of petrol, you will be fighting for the food. Okay, so it's very important. The next region of the drones is the surveying and mapping. Surveying and mapping is one thing which term we use is GIS mapping, geographical information system. This is normally used by road builders and real estate or the constructors or the planners, and they cannot recce each of the area now with the because there are no roads. You need to take a road for going to every place, so they take help of drones, and the drones have some specified cameras, and they capture all the software, all the information about the plane, the terrain, and then they have a 3D mapping software which tries to manipulate to analyze it, to work on this, and they build the 3D model of that terrain, and then the architects and the civil engineers and all the GIS experts can work on it and define and work on their designing where they need excavation, where is the level, where is the light, everything they can do it on the software. So drones are quite helpful in that. Also, if you are working about the climate action, you want to do the counting of the trees, the identification of the trees, the type of the trees, or if you want to, as I was doing in the agriculture, you want to know what is the type of the yield at the moment, where is water, where is not water. In the floods, you want to see where is the water, where isn't, where you cannot, what is the level of the water. So you can take help from this surveying and mapping domain of the drones. So there are companies which are working in Pakistan. So I have taken from a source, I have this image. So you keep on building data with the help of drones, and you can make a 3D model of something which your drone has seen. Also, satellite images are used sometimes, but satellites plus the drones, they together work, and they build a 3D terrain for you. And here, very very important is your 3D scanner sensor, which is LiDAR. So lightning detection and ranging sensor is a very common sensor which is used in this type of drones, and they are used for the 3D making of the picture. Majid Saab and others, do you know how much time I have, so I can try to improvise and control my speed according to it, because it's 12 p.m. now. So how much time I have more to carry on?
Sir, you have 15
Sir,
minutes
you
more.
have only 15 minutes.
Okay, so thank you very much for your reply. So based on all these things and your mapping software, you can have these surveying and mapping drones working for you. So this is another potential area where Pakistani engineers and industries can invest and help our other allied disciplines. So we should start thinking smartly and build the things which are quality based products. So this is something about the surveying and mapping. The second last type is the logistics and delivery drone, because I have about 30 slides. So logistics and delivery drone is another very quiet, interesting field, which is related to taking one payload from one place to another. And sometimes you pick while the drone is flying and you drop it when it is still flying. Sometimes it comes to the ground and takes the thing, and then it lands again and takes off again. So one of the very important field I give the example here is the food delivery, and I'm working on a specific model in my university. So maybe if some of you next time visit me in Park Austria for Hochschule, and if we deliver the coffee or pizza for you, that will be coming through a drone which is made by me, and I'm calling it Kuli. So that portion, that product of Dronetec is working on the food delivery. There are some other models which have been launched. Last week there is some commercial model because it has many hurdles. Delivery process and designing of the drone is very easy, but really implementing it in reality, it has some hurdles, some things. So now we'll talk about it later. Another very important field is the medicine, or the delivery related to the medical field. For example, if I want to have the blood of a specific type needed for a patient within Islamabad, let's say, and from a distance of 5 kilometers, there is traffic blockage or there is some other problem, I cannot move the blood from there to there. And it also needs to have some specific type of storage. So I can make a specific delivery drone which has some packaged insulated box, and the blood can be moved from the patient, from the donor to the patient, and it will be quite quick and quite helpful. Similarly, if you want the medicine, because in medical emergency, sometimes the patient cannot move to the doctor or the doctor cannot move to the patient, but the drone has no limits. It just needs air and it will fly away. So you can deliver the medicine. And sometimes even the if it is a big drone, you can use it as a air ambulance as well, which is my next portion, which is my next field. Okay, so the next region is this my picture when I was working in Holland, and for the first time I worked on the composites and the structures. That was back in 2015 when I was working in a company in Holland. And this structure is based on aerodynamics and glass fiber and carbon fiber. So this structure, the yellow one, is called Velomobile, and this is used for mobility within Holland, and it doesn't work on an engine. It is cycle. It's a cycle, enclosed cycle. And this one and many other things inspired me to work on urban air mobility. So urban air mobility is mobility, it is urban, but this time it is on air. So you are putting everything on a thruster. You are sitting in your delivery taxi or your flying taxi, flying car, and you are moving from one place to another. Let's say you have to go from Park China Center to Faisal Mosque. You don't need to climb everything. You just have to take your flying car and you can go to your other place. All the densely populated cities now, like Dubai and many things, they are working on the flying car. There are about 15 to 20 products which are being made worldwide. Alhamdulillah, I am the first one who's working on it in Pakistan, and I'm talking with the ministries, the investors, different people at the moment. I'm making up my team. My design team is working very in a very hard working manner on that, and I would love to see if somebody wants to contribute in it through Dronetec. And we are trying to make the first flying car of Pakistan, and definitely it will not be one. And this is not as simple as you are designing a car. Let me tell you, designing a car is difficult than drone for me. But what comes after is easier for cars but difficult for the drone system. What comes after is the road. If I have a car built for me and it completes all the certifications and regulations, I can use the road and I can drive it. But the drones, it has very much complex system involved into it. So the drones need if because if the car always will go through a specified road, but the drone can go anywhere. So if there are one drone, two drone, 10 drones, and they are flying simultaneously, they need to have a system. and single air traffic control ATC in airports control that, because ATC works on three people: the driver, the pilot, the ATC theirself, and there's ground control as well. And they three together try to control a plane which comes to the ground and which goes back to the air. But here in urban air mobility you cannot have ATC everywhere, and this is where internet of things and your blockchain wants to work. And if somebody hacks you, you have to make a design a system where all the drones will make define a path. And also if somebody hacks that system, all of you, you were trying to go to Faisal Mosque, but your flying drone will take you to Barrier Down. So it will be a trouble for you. So this is where the big technologies come into play: the blockchain, the IoT, and your cyber security. So information security, all these things together work on it. So I have some students working on it in different universities. I'm working with different professors in different fields where they are helping me in looking to take care of these problems as well. But this is something to come afterwards. At the moment, my idea is to make a safe car for a 100 plus payload, 100 plus kg. So there are few cars available in the world at the moment. In Pakistan, if I'll build the first one, help me out if the regulatory authorities are trying to disturb me for somehow, because this is a problem. When you try to build something new, they try to hurdle you and stop you. So I'm hopeful I will not be facing that trouble, and if I'll face it, wish me best wishes that I'm not disturbed by their this type of steps. So regulations and safety is very important in this field. I have to take care of all the aerospace standards, the safety standards, the local government, the foreign ministry, everything. I have to take care of all the rules and I have to fly them. But the first step is to flying it within my territory where there is no, I have my own control and I can test it. And after I'm done with that, I will keep on moving step by step, and hopefully one day you will see me flying into the building of PEC and conducting this CPD activity physically for you, coming from my university. So hopes are always positive, and let's move to the next portion of the drone types. Yes, one thing I left in the food delivery and the medical delivery, it's very tricky to find who is going to take the delivery. Okay, so it's very interesting in a sense that if you have delivered a pizza to one person, and there are three persons standing, who is the best person to, who is the real person who ordered the pizza? So we have devised a system for that. There is a QR code and other image sensing system, and the drone will first make sure that this is the guy who already subscribed with this drone service, and he will come and go deliver the pizza to that one. And secondly, there will be a camera, and it will be the capturing the image of the delivery person. So the person who took the pizza. So it will be quite close, and I think it is more reliable and safer than your pizza boy delivering to you. Okay, so this is all about logistics and delivery drones. Let's move forward. The last one. The last one of today's talk is search and rescue drone. Search and rescue drone are sometimes when you have some disasters or some areas where you cannot move. Let's say we had that Satpara incident, or we had some people stuck in the floods some time ago, or there are earthquakes, the roads are broken, you cannot move there, or you are looking for some specific person by security agencies, Islamabad police or any police or security agencies were looking for someone. They have the image, they have everything. They're looking for a specific vehicle. The vehicle has gone out of the road or somewhere else. They can take help from the search drones based on their computer vision system. So it will help them increase their safety and security. Also, if there is a bridge which is broken or a building that is about to fall, it is very unsafe to take people in. So you can send your drones. I had a project with my students which were inspecting the after earthquake structures to see if there are cracks or there everything is fine inside, or look for the people who are stuck within the earthquake debris based on their thermal images and everything. So the drones will be able to detect them. And floods and earthquake, Pakistan is quite in that portion of the globe where these things are quite common, unfortunately. And we don't have to look on others yet always. We have to look at our own selves as well. I'm working on a disaster management drone as well through a very good philanthropy company in Pakistan. They are doing a very good job, and they are doing everything for free for the poor people. And they are very quick and energetic when at the times of floods and earthquakes. Even not in Pakistan, but also in other countries. When it was in Turkey or any other place, they were doing their part like play. They were playing their part. So I am working with them as a philanthropist, where they will provide me the hardware and I will provide my technical services to build the disaster management flying machine for them. And you must have seen those news when there were four people struck in the floods in Bala in some north region of Pakistan. It was some far region of from Dir, or it was in Kohistan, when there were four people stuck in the floods for hours. People could see them, and they are few feet from them, but they couldn't rescue them. And they tried their ways, and that in the way of doing that, three of them drowned, and one Ikramullah or Karamullah, something like that, his name is. He is still under the impact of that incident, and he is still having nightmares and bad dreams. So he gets up late at night when he has the visuals of and those images which he has seen, he has gone through. So I tell you, I used to see the same thing. When I saw that picture, I scolded myself that Sohail, you were a little bit late in building your flying car, because helicopters come for the rich, and sometimes helicopters cannot reach every place. They are not they placed everywhere. So we have our ports for the drones nearby, where there are more chances of the floods, and you can have the flying car working for you. And if you are going to save your life with taking some risk, even the regulations don't work at that time, because they have nothing. They have few minutes, and they need something which can pick them up. So I can throw something like a holder or something, and they can hold it, and they can fly from the flooded portion to the dry land. And if I had that car working for me, I would have saved those four lives for me as well. So I have that plans, and I would really love people investing with me if you have the resources with you. So research and mobility, you can always use it for research, and you can use it for the mobility of the people. There is a drone design as well, where you don't have to put the person on the seat. So if a person is on a hiking trip and he got his leg fractured or everything, they cannot pick him up. So what can a drone do? It will go to it, and he will just go like a glider. He will stand up there on the drone, or he will just hang himself on the drone, hold it some pillars, and the drone will take him to the medicine or the near first aid place where he can be taken. So these are some rescue things. Also, in the regions where there are water, excuse me, so they can be taken there as well. Okay, so flooded regions and disaster management, I've talked about. So this is last slide. I'm done with the applications of drones, or we are done with the applications of drone, and now let's talk about the opportunities we have in the drones industry. So if you are not going for any of these application areas, you don't want to buy the complete drones. If you want to buy the complete drones, I'm there are many other companies, 5 to 10 companies have started working. You can work on it. Excuse me, let me take the water. Okay, so but if you want to be not in whole integration portion of the drone industry, but you want to be an expert in a single portion, I tell you, one very big area is the composite structures industry. You can either be the integrator, maker of the structures, or you can be the provider of the raw material, because we don't have the raw material easily available in Pakistan, and if we have, the quality is always questionable. Okay, so composite structures. Second is the testing and certification. So you can come in the testing portion of the drones. If you directly don't want to fly the drones yourself, you can come in the testing of composite structures, motors, thrusters, vibration, energy harvesting, motors, batteries. So there are some portions where you can work on. Also the regulations. So this is another portion where you can use your attributes. because industry is facing a lot of trouble at the moment, and my objective of this CPD was also give you some areas which have the potential. If you start them, you have the customers. Simulation and analysis, you can, if somebody is designing something new, you can have your CAD services, your analysis of services. Like I'm working with Adams. If I have to design the multiple body system, MBD, multi-body dynamics. So that's where simulation analysis can work. Then batteries and energy storages, that have a big potential. There, I'm working near Hatar region. There are some companies which are making batteries, and I'm trying to convince them to push their R&D towards storage devices which can be used for lighter batteries. Lithium is, future. Everyone is talking about them. So lithium lipo batteries, they have potential. And if somebody is able to build smart batteries, green batteries, and which are with specific weight very small and storage very high, can be very good for the drones industry. Blockchain, cybersecurity, and AI. If you have switched to these fields are the tools, and you can use these tools in the field of drones industry. And blockchain, cybersecurity, AI, I little bit talked about it. Blockchain will be used to have the decentralized trust. If a drone is coming for you, you really know that this is the drone I asked for, and the drone will know I will going to the right person. Cybersecurity, to avoid information security or the internal or external attacks given by hackers or softwares or hardwares. And then AI, if you want to have automated drone systems, AI will work into play. Most of the time it's computer vision, but sometimes it's also machine learning as well, so it's not always like that. And the last thing, if you're good in electronics, you can come towards electronic portion of that. So most of the things from the drones are coming off the shelf from Asian market outside Pakistan. But there are people who are working as integrators, and there are very few people. Even people have jobs, technician jobs, like only the pilots of the drones. So, these are some of the fields. So, whichever engineer you are, you're a chemical engineer, you can work in the energy storage devices, composite resins, epoxies, sprayings, fluids. If you are a mechanical engineer, you can work on the structures, on the aerodynamics, on the controllers. If you are on the mechanisms which are trying to build on the drones or different mechanisms. If you are an electrical engineer, you can work on the power electronics, energy storage, motors, controllers, ESCs, robotics, embedded systems. If you are a civil engineer, you can use it for construction. There are construction drones as well being used. You can use it for your surveying, your mapping, your project management of construction, your inspection of the structures. If you are mining engineer, if you are minerals engineer, there are fields where you cannot go hard to reach areas. I just named different applications, but you can use the drones. If you are any other engineer, chemical materials, you can work on the structures, electrical, all the engineerings, transportation engineering, city and regional planning engineering, architectural engineering, any engineering you're working in, you can really make use of drone industry according tailored to your use case. So that was all from my side, and you can follow me on social media. You can write at Dr. Sohail Malik everywhere, whatever for social media or website. I have my website as well. At the moment, it's a little bit down. I have connected it with my LinkedIn, but you can connect with me and you can ask me whatever you want to do in all the fields I'm working on. I'm always looking for good people to have them in my team, and I always look for good collaborators and customers and investors as well. So you are welcome for question and answer sessions now. And before I finish it, I again thank all the PEC, specifically the CPD Department of Pakistan Engineering Council, which gave me this opportunity and ordered me for this CPD talk. So over to you, please.
Uh, Abhi, it is the last session where we have the question answer session. So there are some questions which are be displayed for you, sir, to answer those questions. Then we will conclude. And let me, sir, introduce our Vice Chairman, Balochistan. He is overall head of the convener of the EPDC committee, where EPD activities are being performed. So today he is with us and he will join in the concluding session. So now over to question answer session, and the screen is being displayed.
So I should stop sharing.
Yes, sir. सर ये आपको नजर आ रहे हैं सर क्वेश्चन आंसर्स
जी
क्वेश्चन
जी,
सॉरी
I can see that. I can see that.
सर देन सर आई थिंक कि पहला क्वेश्चन जो है वो आप अगर काइंडली इसको आंसर करें सर देन
Ji, ji. Okay, so first of all, we have a question: how can a drone detect or determine voice frequency of a particular object? It's a very technical and deep R&D question. Normally, voice frequencies are typically not dealt in most of the use cases I have seen, because already the thrusters have their noise in them. You keep on increasing the number of rotors and you will find the drone humming a sound. It will be quite difficult to sit in my office if I have a big drone working at the moment. So that is typically very difficult. But yes, what happens is you use ultrasonic sensors, and those sensors are more than one sensors most of the time, and all these sensors have specific frequency range in them. So based on their feedback system, their transmitter and receiver, you can further close down the range of frequency, but exact frequency it's quite tricky. But of course it depends on the inspection or your sensing system which you have put on your drone. So specifically it can be done on that. So voice frequency of something it is possible, but of course it has its distractions and noise cancellations you have to done before that. The second question: what is the effect of drone upon its operation working? So that is the question. It's a very basic design question. I've talked a lot about it. So when it is working, the drone is basically the first questions when we design the drone is we ask what is the payload, what is the weight you want to put on it, and what is your flight time, and what speed you want it to take onto. So the weight of the drone, when it is given to us as a design specification, we typically define the motor and the thruster for it. Okay, so as the thruster is decided based on the weight of the drone, we design everything on it. There are some drones which are having their payload dropped continuously, like the spraying drone. So if you have a 16-liter spraying drone and its fluid is continuously coming out of it, so its weight is decreasing. So as the weight is decreasing, its dynamics are changing. These dynamics not only affects its battery flying time, but also it affects its vibration and damping system. So when we are putting something to flying, we also see its damping and its overall isolated vibration system when it is working on under different loads. So we define some flutter analysis. First of all, we do its ground analysis, then we do its flutter analysis. We put it in the air, and we have some accelerometers and some sensors on it, and we try to see how does it vibrate. This vibration helps us defining the life of the electronics, because if there will be vibration, the batteries and the connectors can get disturbed and they can stop working. Also, the controller will be having difficulty in stabilizing the drone if it is vibrating, and in the long run it has some cyclic loadings on the system which will cause fatigue and which can cause the drone to fail. So the vibration and damping, most of the time it is neglected by designers, but as a good designer you should have the vibration testing equipment with you where you can see, and also when you vibrate it you also see the response of your sensors, your rotors. So if you are going to take the images of a photo of something, so this vibration will cause distortions, it will be start moving, and that vibration is something related to your weight, because weight is mg, and all the vibration systems are basically depending on the two properties of the system, m and k, mass and stiffness. So when you change the mass, the overall damping ratio is changed. So that's how the weight works in two of the major things I've talked about, but there are many, of course. Then we move towards the third question: which sensors do you use to what means which sensors do you use to stabilize the drone? So he's asking what stabilizes that is basically the navigation system and your gyroscope, which does that. It has something, it is available as a part of the controller, and it defines that what is the orientation of your, because first of all you statically balance your drone, and then you with the help of your controller you define with the help of gyroscope that where does it move, where it wants to move. So the controller has the algorithm in it, where it tries to balance its cg on a specific level. And it keeps on changing the rpms of all the thrusters so that it can have this balance point where it needs to be. Okay, so typically if you are not a very deep analyst of that, if you are not a deep researcher of that, the controllers available in the market have some hit and trial configurations available. So you just balance your propellers at first, you balance your motors at first, you balance your structure at first, and then you configure your motors, and you fix your drone on a platform, and you give different commands, and your controller software normally, which is given by OEM, tells you that how, which motor or which rpm or which things you have to change in order to make your drone stabilized. So you just find good transfer functions of your drone system when you are on the ground. And then you have different types of cycles, one step, two step, three step, and you keep on changing your drone directions and movements, and you try to stabilize the drone. So basically it's the electronic gyro system which is available in the control of your drone. The fourth one is the can flying robots also perform tasks other than aerial photos or aerial films. Of course, I've talked about 6 to 7 types of drones. So you don't have to take only photos or videography. You can do anything. The slogan of my company is let the technology fly. So anything you can do on your ground, you can do it on the drone. Think what you can do: the delivery of the food, the flying, the moment, the Uber Kareem, the inspection. Even you can harvest the crops. You can pick the apples or oranges from the trees used with the help of drones. So anything you can do on ground, you can make use of drones for doing that. Okay, so that was the fourth question. The fifth one is how drone is utilized in irrigating the agricultural land, like sprinkling system. So I talked a lot about it on one of my slides, that when you are spraying the things, anything, you can have a different spraying system, because spraying system has a pump, has a spraying tank, and then it has a nozzle. So based on the configuration of the nozzle and your flow meter, your flow controller, you can increase or decrease the amount, and you can also change the orientation of the nozzles and direction of the nozzles. So where do you want to spray? So that's very easy. You tune it, of course, for the first time, but once it's tuned, it is quite easy. But normally you do one task once at a time with the drone. So if you have started sprinkling system for some specific type of crop, it will be specific for that, because it is very tricky for different crops. So these are the 5 questions. And I also talked about the smart agriculture system as well. That is my favorite. And after 6 to 8 months, hopefully, I will have that smart system working here, and you are welcome to visit it here. Sixth one is it possible to use drones as spray purpose in agriculture? Of course, I'm again telling you, the first product which was made by my final year students in GIK led me to this product, this startup, and of course we started spraying. And I missed one thing. One is fire suppression system. We called this drone system as a a multi-purpose spraying drone, because it could spray different things at a different time. So if you have water into it or ABC powder into it, and there is a fire starting at a top of a chimney or top of a hill, by the time you will reach that, it will be too late. So you can use that drone, and it will go to that spot and it will suppress the fire. There are drones which are using for firefighting as well, but firefighting needs a very big thrust of water. The wire hose is the water hose is very big, and it has a large amount of thrust. So I have seen, you must have seen, you can Google it. There are drones which just take the hose, hold the hose. There is no fireman. There is a drone man. There is a fire drone which is picking up the hose and taking it to the heights, and the hose is going towards your fire big vehicle, and it has water into it. So the drone can spray the water, and it can extinguish the fire. But what we had was a small tank, and what it could do is it could quickly go to the fire station, and throw the water or ABC powder on it. And normally it is fire suppression system, because you can do it in the beginning. Afterwards it is out of control. The smaller drone cannot do it. And thirdly, another thing is that how you sense it is fire. You have a IoT based system of sensors, thermal cameras, and you know which areas of your industry or building or sector has this type of temperature. If that temperature reaches that threshold, you have the information that there is some spark or temperature increasing. So the drone, without waiting for you, quickly goes, and it is a sort of autonomous method. And also we use that multi-purpose spraying drone for a disinfectant. It was a COVID time, and sometime people wanted to spray disinfectant on people, like in Khana Kaaba. If you're doing Hajj and you have to spray disinfectant on something, or there is temperature problem or humidity problem, you cannot take the car inside the congregation. There are large number of people. So what you can use drones. You can use drones to spray disinfectant or water or anything you want to throw on the people. So not in agriculture, you can use spraying of drones in anything you can think of. The last question, the seventh and the last, is to increase flight time. Can drone's battery be charged using solar technology during its flight? The last question, but not the least question, very interesting. One of my students, we were working on piezoelectric energy harvesting. There are two types of energy, renewable energies. One is all energy, renewable energies you take from your environment. Like we have the photovoltaics, or we have the wind energy, or we have the water hydropower plants. All these energy is big amount of energies. But in drones, you cannot have the hydropower plant. You cannot have the wind, because it's already working on the wind. So you have to look for other sources. First of all, I answer your way. You are talking about the solar energy. So in the solar energy, in the you can have photovoltaics, and those photovoltaics can take the energy from the sun, and they can charge yourself. But if you talk about multi-rotors, solar energy is quite tricky in multi-rotors, because they need very big amount of energy. So the solar system will have its own weight if you use the flexible ones and very thin ones, which are very new types of solar cells, or dye sensitized cells, or very unique types of flexible cells. They are not as efficient, but they are lightweight. So they will be giving you some energy to store store it within your batteries, but the thrusters are quickly eating up your energy. So in multi-rotors, it's quite tricky, but it is very interesting if you are going to use it in the fixed wings. And there are solar run fixed wing planes which are flying for hours, which has a very big endurance. There is a company in Karachi which is working on that, and there are many available in the world. And it is a possibility that in future your satellites, the satellites were running very away from you. Then Elon Musk's company SpaceX has given satellites which are very near to us. And the near future, you will have drones flying on some heights where you cannot hear them, but they are at a very closer distance to you, and they can have more inspection and data from you. And those drones need to be powered. Otherwise, you need to bring them back and power them through batteries and charge them. No, they will have their own system. They are big wings, and these big wings are with solar panels on them, and those panels, and they have a very smart aerofoil. I talked about the aerofoil in the beginning, and they keep on flying forever. So the idea is they will never come down to earth. They are like satellites. Once you have once you have launched them, they will fly forever, and they will fly within the area where you want them to, and they will be continuously giving you the data, whether it's a satellite data, because if you are running through something which is near to you, it will be giving you much more data with more resolution, okay, that they are near to you. So that's very interesting question, and it is being utilized. And another thing is the piezoelectric harvesting, which can be used in thrusters or multirotors. That is small amount of energy. You must have seen that when their airplane crashes, they have the black box, and it has some specific power connected to the black box, and all the voices and everything is recorded in it. We can have similar system in the drones. And sometimes if our drones malfunction and fly and crash somewhere, it is very difficult to trace them, because they are no more powered, and our transmitter and receiver stops working. We don't know where they are. So energy harvesting has the property that it makes use of your wind, and it makes use of your composite vibrations. These vibrations causes stress on the material, and you put piezoelectric sensors within them, and they produce some voltage. That voltage is enough to keep some sensors on, and those sensors are they use very small amounts of watts of energy, and these sensors are enough to give you the last GPS signal for some time, and you can trace where the drone crashed. So you can have these type of renewable energies in your drone systems. So hope I have answered the question. So with this, I think all the questions are answered, and I'm also honorable. I'm also thankful to the respective honorable guest from the Sindh. So if you have want to have some more words, please. So I think it's done from my side.
Thank you very much, Dr. Saab. Let me, we have our worthy Vice Chairman Balochistan, who is also convener of this EPDC committee of Pakistan Engineering Council, which looks after the CPD program of engineer for the engineers. So I request him for his concluding remarks regarding this webinar and the activities performed by the Pakistani Council for Development of Engineers.
Uh, Thank you, Kavita. I'm grateful to you for inviting this concluding ceremony. First of all, I am thankful to Dr. Sohail Malik sir for conducting this program, this webinar. Hopefully, a large participant have taken this benefit. ड्रोन के जो इस्तेमाल है आज के दौर के मुताबिक, इसके मुताबिक मैं कुछ कहना चाहता हूँ। मैं खुद के फील्ड में इंजीनियर हूँ, मैं एग्रीकल्चर का डिपार्टमेंट से मेरा ताल्लुक है। यहाँ पे जो लार्ज किस्म के जो रिजर्वियर होते हैं या जो डैम्स बनाए जाते हैं या रोड बनाए जाते हैं, उसके आज के दौर में इसके इस्तेमाल हो, क्योंकि पुराने ज़माने में टेबलाइट का इस्तेमाल होता था, इसके बाद फिर ये न्यूट्रल स्टेशन की मतलब इस्तेमाल होती थी। अब इसके साथ साथ वक्त के साथ साथ जिद्दत भी आ रही है, जहाँ पे आरटीके और ड्रोन टेक्नोलॉजी का भी इस्तेमाल हो रहा है। हमारे फील्ड में इस वक्त हम इस्तेमाल भी कर रहे हैं, हमारे कंसल्टेंट करके काफ़ी काम कर रहे हुए हैं, जो कि वक्त के जिद्दत के साथ ये लोग इससे फायदा लेते हैं। इस टेक्नोलॉजी जो काम जो पहले महीनों में होता था, वो आज दिनों में हो रहा है, उसके फायदे भी आ रहे हैं। तो हमें जाहिर है, जब टेक्नोलॉजी आगे बढ़ता जाएगा तो लोग उससे फायदा भी उठाते जाएंगे। तो इस वक्त भी एग्रीकल्चर में आप असेसमेंट करेंगे रेवेन्यू के हवाले से क्रॉप, तो उस पर भी आपको फायदा होगा, उस पर भी आप उसको जल्द असेसमेंट कर सकें। इरिगेशन के कैनाल सिस्टम में उनके सर्वे में भी बड़ा काम आ रहा है, इवन के रोड में बड़ा इसका इस्तेमाल हो रहा है। तो इसको आने वाले दिनों में यकीनन टेक्नोलॉजी के साथ लोग इससे फायदा भी उठाएंगे और लोगों को उसमें इन होना चाहिए ताकि ज़्यादा से ज़्यादा फायदा हो। जिस तरह डॉक्टर साहब ने कहा, पेस्टिसाइड एग्रीकल्चर की तरफ भी लोग जा रहे हैं, तो वहाँ पे भी मतलब इसका इस्तेमाल है। तो ये बहुत सारी चीज़ें हैं जिसका करेंगे, पेस्टिसाइड है, फर्टिलाइजर जब आप इस्तेमाल करेंगे वहाँ पे भी इसका इस्तेमाल होगा, तो इसके बहुत सारे फायदे होंगे। तो मैं शुक्रगुजार हूँ साल में इसको प्रोग्राम किया। तो ये जो सीपीडी का थोड़ा सा मैं बता दूं कि सीपीडी जो प्रोग्राम कंटिन्यू जो प्रोफेशनल डेवलपमेंट है, ये तो एक्टिविटी चल रहे हैं। इसमें सोफा जो प्रोग्राम किए हैं 2010 में हमने कोई 30 सीपीडी एक्टिविटीज हमने रखे थे, और मई और जून 2023 में इंशाल्लाह 47 और भी इसमें हो चुके हैं। और बाकी आने वाले वक्त में भी इसी तरह मजीद हम बढ़ाते हैं। कुछ फिजिकल भी अपने साथ कुछ सीपीडी ये जो इस पे आए थे सीपीडी जहाँ के दरमियान कोविड की वजह से फिजिकल नहीं हो सके, तो इनार पे हम चले गए, और उसके साथ वो भी काम भी हमको हो रहा है इस पे, लेकिन अब कुछ फिजिकल भी हमने स्टार्ट किए हैं। तो ये नंबर ऑफ पार्टिसिपेंट जो 2021 और 22 में हमारे पास 4,99,000 हमारे पास नंबर ऑफ पार्टिसिपेंट्स थे, उन्होंने इस्तीफादा हासिल किया। तो सर्टिफिकेट जिनको मतलब ये मिल चुका है। तो कोशिश करते हैं कि पार्टिसिपेंट इसमें हिस्सा लें ज़्यादा। एक तो ये कि ये जो सीट्स है वो भी इनको मिलते रहेंगे, और उसके साथ साथ वो नॉलेज भी गेन करेंगे। तो हमारी कोशिश है कि और भी प्रोग्राम इसके साथ रखें, जो इंशाल्लाह वक्त के साथ साथ मुख्तलिफ टेक्नोलॉजी मुख्तलिफ सब्जेक्ट मुताबिक पे हम प्रोग्राम रखेंगे, और उनसे लोग इस्तेफादा हासिल करेंगे। तो इन बात के साथ मैं तफक्कुर सोहेल साहब का भी मशहूर हूँ कि उन्होंने बड़े अच्छे तरीके से कंप्रिहेंसिव तरीके से मैं ड्रोन्स के बारे में मालूमात दी, और लोगों ने इससे फायदा भी उठाया, नॉलेज उन्होंने गेन किया। थैंक यू सर।
थैंक यू वेरी मच सर डॉक्टर साहब। और आपका जो है ये रिकॉर्डेड इंशाल्लाह हम वेबसाइट पे पाकिस्तान काउंसिल के जो लिंक्स हैं वहाँ पे अपलोड करेंगे। और अगर कहीं सर कोई क्यूरीज कोई आए इंजीनियर की तरफ से मजीद कुछ सवाल तो आप उनसे मालूम करेंगे, और काइंडली उसमें हमें थोड़ा जो है सपोर्ट ये चाहिए होता है कि जब साहब उनको हम advise करते रहें। दूसरा सर जो सर्टिफिकेट्स जो पार्टिसिपेंट्स हैं उनको हम ईमेल के जरिए ई सर्टिफिकेट्स भिजवाते होते हैं। तो एज अ रूटीन मैटर वी विल आल्सो डू द सेम, all the emails given to us by the engineers, we will transmit their EPD, CPD certificate through those emails. So with this हम आज का ये सेशन सर इख्तिताम करते हैं, और इंशाल्लाह अगले किसी ऐसे ही प्रोग्राम में दोबारा इंजीनियर्स के साथ बातचीत होगी। तब तक अल्लाह हाफिज सर। थैंक यू वेरी मच।
Allah Hafiz.
वो जी आपको पता है ये सारे